जसको छ मैले शेयर गरिसकेको छु हैन
एउटा सुन्नु न तपाईको नम्बर दिनु न बरु म तपाईसँग पछि बरु कुरा गरौँला
दाइ
नम्बर पनि म त्यहीमा लेखिदिएको छु ल नम्बर पनि हेर्नु त 9
दाइ
भन्नु न
दाइ त्यो हाम्रो त्यो ग्रुप युएसएफ पार्टिसिपेट ग्रुपमै हाल्दै भइहाल्यो नि सबैजना त्यही त छ नि
ए त्यो के भन्छ
त्यसमा त नहालौँ ग्रुपमा नहालौँ त्यो ग्रुपमा नहाल्दा हुन्छ बरु इन्डिभिजुअल इमेल गर्दिउँ के इन्डिभिजुअल इमेल
जसको छ मसँग हैन म गरिरहेको छु
तपाई आफ्नो नम्बर दिनु न म कल गर्छु
अनि यो कन्भर्सेसन कसैले त लेख्या छ त उ थ्यांक यू भनेर अरुण जीले लेख्नु भो त
ओइ मेरो खुलेन यार त्यही भएर त भने एकछिन यहाँबाट खुल्छ
अनि दाइ 4 घण्टा क्लास गर्दा के होला कसैलाई के फरक पर्ला
तपाईको नाम के हो
खगेन्द्र
संजय कुमार कुशवाहा सोच नाली गेस्ट कृष्ण विकास सुरेश शर्मा गेस्ट
अनि नभई अहिले के हुन्छ नि एउटा बरु ग्रुपै हामीले क्रिएट गर्यो भने एकजनाले गर्नुस् न कसैले
तपाई के नाम भन्नुभयो आफ्नो
खगेन्द्र त्यही ग्रुपमा हेर्नु न मेरो नाम होला त इयासाबला ग्रुपमा
यो पार्टिसिपेटमा त नाम देखिरहेको छैन 12 जना इन मिटिङ देखाइरहेछ
खगेन्द्र कुमार
देखाए के गर्ने यसमा तपाईको नाममा क्लिक गर्दा केही देखाउँदैन
त्यो हैन त्यसको छेउमा सानो मेसेजको सिम्बल छ के त्यो पार्टिसिपेन्टमा क्लिक गर्नु हुँदैन त्यो सानो त्यो छेउमा छ के ल यो पछि गरौँला है त
तपाईको नम्बर दिइराख्नु न प्लिज
980
80
68216
म अहिले कल गर्छु है अर्को नम्बरबाट है
ल
Okay, we'll just give 2 more minutes and then we'll carry on. Can everybody see the screen with environmental systems?
Yeah, we can see it.
Everybody got that one? Brilliant. Suresh, you got your hand up, sir.
I can clearly see the environmental system. So hands off.
Fantastic. Technology's working for us today then.
Yeah, absolutely.
So just give them 2 more minutes and then I'll carry on. Just while we're waiting, has anybody got any problems with or questions from anything that we covered yesterday? No, that's good. And I sent Yadav some questions that he'll forward on to you just to help with revision. The other thing I did was found out the question breakdown for you guys. So again, Yadav's got a copy of it and he will pass on the relevant information. The amount of questions is a ballpark figure. They might vary slightly, but the overall amount of questions will remain the same. So if it says for hydraulics, I think you get 12 questions. It could be 11, it could be 13. It might vary very slightly between the different subsections. But the figures I've given you are a good guide to the areas where the majority of the questions are going to be based. Yeah, so that they'll get passed on to you. Right. That's everybody starting to arrive now. Okay, right. What we'll do then, guys, we'll rattle on, and what we're going to look at today is book 2 for our 11, 12, 13 adventure together. Looking at book 2, and book 2 is environmental systems, the air conditioning side of it. Air conditioning, obviously, very important in the aeroplane to keep people alive. When we're getting up to the sort of altitudes that the aircraft's going to operate at, obviously very, very, very cold. So we need to introduce some sort of conditioning to keep the air at a livable level for us. Not only that, we don't want it too hot. We're going to use the engines, as we'll discover later on. We're going to use the engines as a source for our warm air. We don't want it too hot, so we need to be able to control the temperature to a comfortable level in the aircraft. The other thing with the aeroplane as well, we'll do it as a totally separate subject, but if we're flying at altitude, we're going to need to pressurize the aeroplane as well. So the air that we're going to use for pressurizing, we need to treat that again to allow us a nice, comfortable environment in which we're living, if you like, or in which we're flying. There's number 16. Right, so that's what we're going to look at today. And again, it's a fairly simple subject. It's something that you'll be familiar with. You might not realize it, but you'll be familiar with it. So we'll just have a gentle plod through the different systems. again, there's within the notes, some of the information's repeated, but it'll become obvious why as we go through. So air conditioning systems we'll have a look at now. Yeah, when we talk about conditioning systems, we sometimes refer to them as bootstrap systems. And bootstrapping is just a technique where we want to bring something into its desired condition through its own action. That's all that bootstrapping means, technique through which something is brought into the desired state through its own action. So what we're going to do is we're going to take hot air from the engines and we're going to make that air work. And in making it work, we're going to take the heat out of that air and we're going to bring it down to a usable temperature. So it's actually cooling itself, and again we'll see how it manages that. But when it talks about bootstrapping systems, that is what we mean. Yeah, the technique through which something is brought into its desired state through its own action. Yeah, the way we do it on the aircraft is through air conditioning packs. Generally, the packs are duplicated. Again, that gives us redundancy, and it makes sure that if we have a failure in one engine, that conditioned air is still going to be supplied via whatever system we're going to use. Pack, we call it the packs, and we get the idea that the pack is just a load of components bolted together into a pack. But pack is actually an acronym for pre-air conditioning kit. Yeah, or preconditioning air conditioning kit, I think it stands for. It's a Boeing acronym. So although it works for us, we call it the packs. That's where the term came from. Yeah, and the pack itself comprises of a number of components, and where they're located on the aircraft, obviously dependent on the type of aeroplane we're gonna be working on. As we'll see as we go through, there are different methods of cooling the air down. Kind of depends on the type of aircraft that we're going to be working on. Your larger aircraft, your 737s, your turbine aeroplanes, tend to use the conditioning packs, the air cycle machines, where they're going to bleed air from the engines and run that through a series of components to get it all nicely chilled down to the temperature we want. Turboprop aircraft, I won't say all of them, but a lot of them use displacement blowers. Again, we'll have a look at that later. Helicopters tend to use a different type of conditioning pack because of the environment that a helicopter works in. And again, we'll have a look at that. It's relevant to some fixed-wing aircraft as well. But just up on the screen there, example of the conditioning pack and the components that it comprises of, all tucked away in the belly of the aeroplane quite nicely. And the main component in the pack is the air cycle machine. Again, we'll be having a look at how the air cycle machine works, how that interacts with the other components. We may well need conditioning on the ground. Again, if you're in the middle of summer out in Kathmandu and the aircraft's sitting out on the apron waiting to go, again, we need to get cooling air in to keep the passengers comfortable. So we might well need an external source of conditioned air as well. So the aircraft will use bleed air from the engines, we'll cool that down, pump that into the aircraft, again, keeping passengers nice and comfortable. But if we're sitting on the ground, we might need some sort of external ground equipment an external cooling trolley that we can plug into the system to make sure that cooling air is provided if we've got a delay for whatever reason, if we're going to hold. Just quickly make sure that I've not missed anything there in the intro. Yeah, so the air supply, it talks about the air supply for the conditioning system. From the engines, we mentioned that. From displacement blowers, I've talked about those, and we'll come on to those a bit more detail later. Ground equipment, yeah, the control of cold air on the ground. If there's no engines running, we can use external sources. And the other thing we might use is the APU. Yeah. Again, we can, as we saw yesterday with our cooling pack ventilation, we can use the APU to induce a flow of air into the pardon me, into the conditioning system should we need to, should we want to. The whole thing is switched on from a control panel in the cabin. Again, we're using, I think it's a 737 example that it uses in the notes, but depends on the type of aircraft you guys are going to be working on as to what your control panel looks like. But it's going to perform pretty much the same function. It will give us the option to turn the system on and off. Yeah, so somewhere on there, there'll be an on-off switch, and that's going to allow the bleed air into the system once the engines are up and running. I've got the bleed air coming through. We need to monitor the temperature of that bleed air, so that there'll be a temperature gauge for the ducting. Again, just to make sure that the air is running at the right temperature. We're going to have some sort of temperature control. Generally, that's either automatic or manual control. In this case, we've got both on the one selector. So if we get a failure in the auto system, we can adjust using the manual. We'll have some sort of indication of what our conditioned air, what temperature it's going to be running at. In this particular case, we've got a selector switch, so we can see either what the duct temperature is or what the cabin temperature is. So the crew have got an idea of how toasty and warm you are, or how freezing cold you might be. Lovely. Sorry, I'm just looking to see how many we've got. 25 again. Fantastic turnout. And back to my slide. Yeah. We'll look at the ram air door side of it in just a minute, because that plays a big part in the cooling of the air. So we'll be able to see how the ram air is acting, how we can balance the temperature of the air that we want into the cabin. Everybody okay with that? Yeah, excellent.
Yes, sir.
Right. What we're going to do then is we are going to take air from our engines. Obviously, you've all done your module 15, so you know that the air coming off the engines is going to be pretty hot. Yeah, so we need to bring that hot air down to a usable temperature, and the way we do that is via the cooling packs. As a generic system, yeah, normally there's a pack associated with each engine. So we've got number 1 engine, number 2 engine, 2 cooling packs, yeah, and the engine feeds, there's a cross-feed isolation valve between them, so each engine's looking after its own pack. If we've got a failure in one of the cooling packs or a failure in one of the engines, we can open the isolation valve and allow one side to cross feed to the other. The engines are, I was going to say, so powerful. Yeah, it's not really going to have a detrimental effect running both packs off one engine, but we have that option there if we want it. Just concentrating on the number 2 side, then the number 1 side is pretty much duplicated. Apart from the trim, I'll show you that in a minute. In fact, we'll look at the left pack. It's easier. We have that feed from the APU should we need it. If we want to run the thing on the ground, or if we get an incident in the air, we've got the APU as a source of bleed air should we need it. Normally we'll use the engines. The APU will have an on-off switch, select a upline. The pack is opened via what they call the pack valve, yeah, and that is selected from the cabin. So we've got the engines up and running. The crew will switch on the conditioning packs, and that hot air from the engine will be directed into the cooling pack. In this case, the left-hand pack. Some of that hot air from the engine will bypass the cooling pack, and it will be directed straight to the mixing chamber. The remainder of that hot air will be conditioned within the pack. We'll make it work. We'll bring the temperature down to a good level, actually pretty cold, and we duct that cold conditioned air again into the mixing chamber. At the mixing chamber, the hot air and the cold air will circulate together, and they will leave the mixing chamber at a predetermined temperature. So what we select for the cabin, yeah, we can take that conditioned air, and we can bring it to the temperature that we want. And we're going to duct that off to the main manifold that runs down behind the baggage racks and down the centre of the cabin, your main manifold. And that's going to pump that conditioned air into the cabin, keep the passengers nice and toasty. You'll notice on the left-hand side, we've got a tapping from the mixing chamber there, not only to the passenger cabin, but we're going to take the air to the flight deck from the left-hand side as well. So the crew have got their own separate feed. They don't take the conditioned air from the passenger cabin, because you know what aircrew are like. They're very precious, so they want to be looked after. So they get their own little feed from the mixing chamber. We've also got a recirculation system. Again, we'll look at that in a bit more detail in a wee while. But the recirculation system is there to conserve some of the air that we're using. We're not just going to pump air in, treat it, pump it back out again. What we can do is bring some of that air back and reuse it, nicely filtered and all the rest of it. And that's your basic system layout. Yeah. Again, just a direct copy of it, but showing how from the engine via the cooling pack, and then that air is going to get pushed up into the manifold, yeah, that runs down the center of the aircraft. That air is then going to circulate around the passenger cabin. As it circulates around, it's also going to get taken away via little louvers at foot level, yeah, and it's going to get ducted down behind the wall of the cargo compartment. So it's not only keeping the passengers nice and warm, it's also conditioning the cargo compartment. So whatever cargo we're carrying, we're kind of going to preserve that as well. Yeah, so the cargo compartment's going to be looked after. Once that air's been circulated through the cabin, it will be discharged from the aircraft via an outflow valve. For most aircraft, most pressurized aircraft, the bleed air that we use for conditioning and the bleed air we take for pressurization, both from the same source, both the same air, all we're going to do is pump the air into the cabin and release the air slowly from the back end. So that conditioned air used again for pressurization a lot of aircraft, and then vented out to atmosphere at the back end of the aeroplane. The ram air inlets, we mentioned the ram air earlier, and ram air is going to be our cooling medium. Yeah, and we're going to use ram air to help bring the temperature of the engine air down to a usable level. But we need to control the amount of ram air that we're allowing in. So we do that by having an adjustable duct. The adjustable duct, there's just a little deflector plate at the front. And depending on how much cold air we want to allow into the system, yeah, we can adjust the position of the deflector door. Some air will be ducted into the system. Some of it will be deflected past the intake. And by moving that ram air flap, if you like, that ram air duct door, we're adjusting the amount of cold air that we're allowing into the system. Anybody got any questions on any of that little lot?
Excuse me, sir.
Yes, sir.
So here pack means including everything like SEM, heat exchangers, water separator, including everything is called pack.
Yes, yeah. The pack is the collective name for all the components. They're just all grouped together.
Okay, sir.
Okay.
Yeah.
Jim, the previous slide.
Jim, the previous slide. That one?
Yeah, no, with that diagram, the other colored one.
Yeah.
Yeah, for the flight deck, the only from supplies from the left pack, not from the right.
No, the supply comes from the left hand and the right hand engines. Yeah, I just said the left hand one because they're duplicated. So the right hand engine will provide hot air via the pack valve into the right hand pack. The right hand pack will then send some hot air to a mixing chamber. The rest of it will condition into cold air, and we mix the hot and the cold in the mixing chamber, and that will bring it down to the usable selected temperature. The left pack does exactly the same. Yeah, so the isolation valve is separating the left hand and the right hand side. The only difference is on the left pack is we're going to take a tapping from the mixing chamber there, and we're going to run that off to the flight deck. With the right hand pack, that just goes off to the passenger compartment.
Okay, and this cold air, that is from the ambient ram air.
I'm going to come on to that, but no, what we're going to do is we're going to take the hot air from the engine, yeah, and we're going to bring the temperature of that air down. Yeah, so that engine air, we're going to cool that right down, and that will become the cold air. Some of the engine air, we're going to bypass the pack. We're not going to condition it, and we're just going to push that straight into the mixing chamber. We'll see that in a minute as we come on to the next slide.
Okay, thank you.
All right. Everybody else okay with that? Any questions there? Deathly silence. That's what we like to hear. Okay, so the system itself then, this is the cooling pack and the components within the cooling pack. what we have is the pack valve. The pack valve is basically the on-off switch. So as I turn the, I've got the engine turning. Yeah, if I open the pack valve, that is now going to allow engine air, hot engine air, into the cooling pack. Some of that hot air is going to go straight through a mixing valve into the, pardon me, into the mixing chamber. The rest of that hot air is going to come down and it is going to go into a heat exchanger and then into the air cycle machine. So what happens? Start the engines up. We're going to go flying. Yabba dabba do. It's a nice warm day. Yeah. So we want to bring the air down to think of a number. Let's say what's a nice comfortable number? 20 degrees. Yeah. So we want to bring the air down to about 20 degrees. So we'll open the pack valve. We turn the air conditioning system on. Some of that air conditioning air will go straight through a mixing valve, straight into the mixing chamber, small tapping of hot air. The rest of it is going to get ducted down via a heat exchanger. That heat exchanger is just an air-to-air heat exchanger. Remember we were talking about ram air earlier? Yeah, so the ram air is going to come up through the ram air scoop. Depending on the position of the deflector door, depends how much ram air we're going to allow in, and that ram air is going to get blown across the heat exchanger, the primary heat exchanger. Yeah, that's going to start cooling that hot air down. It's going to take some of the temperature away. The cold ram air blowing over the heat exchanger, the hot bleed air going the other way. It's gonna get cooled down, and then that temperature is pumped out via the exhaust. Yeah, that air now has had some of the temperature taken out of it, and it's going to go on then into the compressor side of the air cycle machine. The air cycle machine is a turbine compressor. The turbine and the compressor are on a common shaft. So as the compressor starts turning, yeah, the turbine is going to turn at the same time. So that hot air now comes through the other half of the mixing valve into the compressor, yeah, where it is, as the name suggests, that hot air is then compressed. As it gets compressed, the pressure is going to increase. If pressure increases, temperature increases. So now we've taken heat away, but we're raising the temperature again via the compressor. That air from the compressor goes through another heat exchanger, the secondary heat exchanger, where again ram air is blown across that heat exchanger, and we take away more of the temperature. So even though we're heating that air up, going across that secondary heat exchanger takes away a great deal of the temperature from the air. It comes out of the secondary heat exchanger up to the turbine. Yeah, the turbine and the compressor on this common shaft. As that air hits the turbine, it expands, and because it's expanding, it's dropping pressure. Because it's dropping pressure, it's dropping temperature. That air is still warm, so we need to take away the last remnants of heat, and we do that by changing that heat energy into work energy. So the turbine, via that common shaft, drives the compressor, and as the turbine's driving the compressor, we've converted that heat energy into work energy. Yeah, so now the temperature has dropped even further, and that conditioned air, now that cold air, is going to go through a water separator and up to the mixing chamber. Once it's up at the mixing chamber, yeah, the hot air that you allowed through initially and the cold air swirl together, they mix together, and then they will be ducted off to the distribution manifold at a selected temperature. To achieve that selected temperature, we've got the mixing valve. And the mixing valve, I'm just going to flick to... Can everybody see my picture at the bottom of the...
Yes, we can
Yeah.
see your video.
My happy face.
Mhm.
The mixing valve is a little plate like that, and as one valve opens, the other one closes. Yeah. So if I've got hot air running through the mixing valve in one direction, cold air in the other direction, by adjusting the positions of the two valves, I can adjust the amount of air that's being mixed together. So as I start to close off the hot, as I start go back to the coloured picture, the mixing valve in the hot air line, if I start to open that up, that's going to allow more hot air through to the mixing chamber. Because I'm allowing more hot air through, at the same time as that's opening to allow more hot through, the other plate in the mixing valve is closing to reduce the amount of air that we're sending through the air cycle machine. So the mixing valve is there to balance the amount of hot and cold air that we're allowing through. Everybody okay with that? Can you see that okay?
Sir, you're okay.
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 Yes, sir.
Excellent. Right. So we've opened the pack valve. We've adjusted the controller. I'll come on to that in a bit more detail. So the mixing valve now is allowing so much hot air in the mixing chamber. The rest of that hot air is going through a primary heat exchanger, through the other half of the mixing valve, yeah, through the compressor, through the secondary heat exchanger, through the turbine of the air cycle machine, and into the water separator. Once we've taken that water out, we can throw it up to the mixing chamber where it mixes with the hot air, and it will go on to into the system at the required temperature. The ram air, the amount of ram air that we're going to let through, is adjusted by the deflector door, and automatically controlled. So that there's temperature sensors. We'll again come on to those in a minute. Those temperature sensors are going to automatically adjust the amount of ram air that we're allowing through into the heat exchanger. That ram air absorbing the heat from the hot engine air, and again that's vented overboard, and that's going on all the time the system's running. Other thing to point out just while we're on this slide is a little turbofan here. That's from the ram air system, the APU. Yeah, and what we do, we turn the APU on. That provides a bit of air that's going to run a fan in the ram air exhaust. Yeah, as that fan's running, it's pulling air across the heat exchanger. Yeah, so now if we're sitting on the ground, we haven't got the ram air but flowing through the aircraft. We haven't got that forward motion. We can induce a flow of ram air just by getting the APU to run that little turbo fan. Yeah, so we just take a tapping of air, blow that across the turbo fan, that runs, and it will suck air through the ram air inlet across the heat exchangers. So a facility for on the ground. Are we okay with that? Any problems there? Yeah. Again, just showing us what the thing looks like. This is an example of an air cycle machine. And all it is a compressor at one end, turbine at the other end, and the two of them are joined together by a common shaft. So as air's introduced into the compressor, it gets compressed, it gains temperature, it goes down to that secondary heat exchanger, through the heat exchanger where it's cooled down, and it comes back up into the turbine side. As it comes into the turbine, that air expands, pressure drops, temperature drops, and the turbine, via the common shaft, that turbine drives the compressor. And by using the turbine to drive the compressor, we're converting heat energy into work energy. So we're losing that heat, and now we've got cold air coming off the other end of the air cycle machine. Again, this is just to give you an idea of the layout on a larger aircraft. Obviously, different aeroplanes. It's all the same sort of principle, but slightly different layouts. Has anybody got any problems there at all?
Okay, Mr. Campbell. What is this line from the water separator to the ram air in? There is one line and it's connected to the
That one.
In the this one.
Right.
Blue line.
Yeah, that is I'm going to come on to that when we talk about the water separator. But we're going to take moisture out the system. What we don't want is the system freezing up. Yeah. So what happens is the water separator takes the water out, and that water is drained away. On some aircraft, the water is sprayed back into the system, and it acts as I can't remember the physics for it, but it helps with the cooling process. So sometimes we'll squirt that water back into the system, normally at the face of the heat exchanger, and by spraying that cold water onto the face of the heat exchanger, it helps with the heat exchange process. Yeah.
It's just for the water separation.
Yes. Yeah, okay. And I'll come on to that in a minute. The other thing, I'm pleased you actually mentioned that, though, because the bit that I should have said, just before we go into the compressor side, again, there's a little bypass around the air cycle machine. And that bypass takes a wee tapping of hot air. Yeah, and at the outlet of the turbine, it introduces a little bit of hot air. So the cold air that comes off the turbine is always kept around about 35 degrees Fahrenheit, which I think is 1.7 degrees C. The reason for that is we don't want the air that's coming off the turbine to freeze. Yeah, so we don't want ice being introduced into the system, otherwise it would just create havoc. So we keep the air coming off the turbine just above freezing temperature using this 35 degree switch. Yeah, so there's a little thermostat on the water separator. Again, we'll look at in a minute. But that thermostat is monitoring the temperature of the air in the water separator. If it goes below 35 degrees, it opens a little valve up, which allows more hot air to bypass the air cycle machine. Okay with that?
Okay, I got it.
And sir, one more.
Say again.
The previous slide. No.
That one?
One more. Yeah, this pack valve, all the air is taken only from the engine only. The bleed air is the beginning of the pack valve, hot air.
Yes, that air here before the pack valve is bleed air from the engine.
Okay. That's right. So what is this pack valve then?
The pack valve, all the air conditioning kit, yeah, is in one location. and we call that the air conditioning pack. So the air cycle machine, the cold air unit, the heat exchanger, the water separator is all considered to be the air conditioning pack. It's just a collective name for the components.
Okay.
Yeah. So we take the hot bleed air, and we by switching the pack valve on, we're opening that that valve, and we're allowing the engine bleed air into the cooling pack, into the system. Yeah, okay. Some of that hot air will go through a mixing valve into what they call the mixing chamber. The rest of it will go through the cooling pack. That cooling pack comprises of a primary heat exchanger. So the hot engine air will go through a primary heat exchanger where it will meet cold ram air. That's going to take some of the temperature away from it. It will then get pushed up again via the mixing valve into the compressor side of the cold air unit. As it goes into the compressor, it's obviously squeezed together, the pressure's raised, the temperature's raised. That hot air goes through the secondary heat exchanger, and again the ram air is blowing across there, and that is going to reduce the temperature of the hot air even further. So what we're doing is, remember we talked about bootstrapping. We're making that air work. We're making it work hard to take the temperature out of itself. So it'll go through the secondary heat exchanger, and then it'll come up to the turbine. As it comes into the turbine, that air expands. As it expands, the pressure drops, the temperature drops. And that'll bring the temperature of the air right down. Yeah. The remaining temperature is removed by converting the heat energy into work energy. So the turbine is, via a common shaft, is driving the compressor, and that is going to take away the remaining heat from the air. That air now is going to get pumped into the water separator, but it's going to go into the water separator at round about 35 degrees Fahrenheit, which is 1.7 degrees C, I think it is. It keeps it just above freezing and prevents any ice formation in the system. The water separator, as we'll see in a minute, takes away the moisture. Not on every system, but on some systems, that rather than dumping that moisture overboard, what they'll do is they'll direct it back into the system, and they'll spray it onto the face of the heat exchanger, the secondary heat exchanger. And by spraying that cold water onto the heat exchanger, it just makes the heat exchanger more efficient. As I said before, I can't remember the exact physics over it. Somebody did explain it to me once, but I've kind of forgotten it. But it just makes the heat exchanger more efficient.
Okay, and this deflector, and this deflector door is how it is controlled?
It's controlled automatically via temperature switches. Again, I'm just going to come on to that if you can give me a minute.
Okay.
I'll show you how that works. But all we're doing with that door is just positioning it so depending on what position it's in, depends on how much ram air it's going to allow into the system. Again, don't think this is in the notes. It's more for the ab initio guys, but it's just showing we're going to take the bleed air from the engine. We're going to run that in bleed air into the system, turn the pack on, and we're going to run that air through the primary heat exchanger, up through the cold air unit, through the secondary heat exchanger, and then we're gonna pump it on into the system. Once it's gone from the mixing chamber, it's going to go up to the distribution ductwork in the cabin, where it'll get pushed on into the cabin. Bit of a fussy diagram, but just to give you an idea. Everybody okay with that? Any questions there? No? Okay then, right. So, pack valve, bleed air, mixing valve. We've talked about the mixing valve. Yeah, as the mixing valve operates in the hot air line, it'll open the hot air line, it'll close off the cold air line. So it's balancing the amount of air that's hot and cold that's going into the mixing chamber. It does this via a temperature controller. Now the temperature control selector is in the cabin. Yeah, and that temperature selector feeds an input into a temperature regulator. The temperature regulator is what is monitoring what's going on. 10 o'clock, 29 folk. Yeah, the temperature regulator is kind of the brains of the outfit, and it's the temperature regulator that's looking at what's going on. It's monitoring what's happening. So let's say, well, I've got an automatic or a manual selection. Yeah, so let's say I want the cabin air to be at 20 degrees. Yeah, we like 20 degrees. So I'll select 20 degrees on my temperature selector. The temperature regulator will say, right, that's what temperature he wants. Yeah, I'll keep monitoring that. Within the cabin, we've got temperature sensors. There'll be a backup one in there as well, but we've got a cabin temperature sensor, and that is telling the regulator what temperature the cabin is at. The regulator wants to make sure that we're maintaining that 20 degrees, so the regulator is talking to the mixing valve. Yeah, and it's keeping the mixing valve in the right position to allow the right amount of hot air into the mixing chamber and the right amount of cold air into the mixing chamber. So let's say then that we've got 20 degrees selected, and the temperature starts to drop a bit. Yeah, it drops down to, let's say, 18 degrees. The cabin temperature sensor is monitoring that, and it'll say to the regulator, hey up, it's getting a bit chilly in here. Yeah, you need to give us a bit of temperature back. The temperature regulator then will adjust the position of the mixing valve. We want to warm the cabin up, so what it'll do, it will start to close off the amount of air that we're allowing into the air cycle machine, and it will open up the amount of hot air from the engine that's allowing into the mixing chamber. That air is all mixed up and pumped into the cabin, and as the temperature rises, yeah, the temperature sensor will say to the regulator, yeah, that's spot on, and the regulator will hold things in that balanced position. We carry on a bit, and the temperature starts to rise. We get warmer and warmer. Yeah. Again, the cabin sensor is going to talk to the regulator. The regulator is then going to close off the mixing valve in the hot air line, reduce the amount of hot air that we're allowing in the mixing chamber, and at the same time, it's going to open up the second half of the mixing valve that's in the cold air line. So now the air that's coming from the engines through the primary heat exchanger, we're going to allow more of that air now via the mixing valve into the air cycle machine via the secondary heat exchanger. Yeah, and that secondary heat exchanger taking away that heat into the turbine. So now we've got more cold air coming into the mixing chamber. Again, that's pumped into the cabin either way. The temperature sensor senses that the temperature's dropping, says to the temperature regulator, that's magic, we're back to the 20 degrees, hold it there, son. So that the regulator is monitoring what's going on, and it's adjusting the mixing valve to maintain that nice constant temperature in the cabin. The other two sensors that you'll notice in the line in the cabin, and again they're talking to the temperature regulator. What these sensors are there for is to prevent a big rush of hot and cold air as the temperature changes. So the anticipator is looking at the temperature in the duct, and it's saying to the regulator, you need to get ready to move here. Yeah, and it's going to make sure that the mixing valve moves in a nice, steady, controlled manner, rather than having a great rush of cold air into the cabin. The limit sensor makes sure that it just doesn't go too far. So all it's doing is damping down the effects of the movement of the temperature controller, so we don't get great big blasts of hot air, really hot air, and we don't get big blasts of cold air. The heat exchangers, let's come on to onto that one. Yeah, as we said before, we've got the hot air going through a primary heat exchanger. That primary heat exchanger taking away the heat, yeah, allowing the air through into the compressor side of the cold air unit or the air cycle machine. And there's sensors in the lines coming out of there. Yeah, there's a compressor overheat sensor, and that's monitoring the temperature of the air that's coming off the compressor, and there's a ram air controller in there as well. And these two sensors are looking at the temperature of the air that's coming off the compressor, and it's going to adjust the position of the ram air deflector. Yeah, so the sensor sending a switch to a little motor that's adjusting the position of the deflector door, which in turn is regulating the amount of air that we're allowing to blow across the heat exchangers. If I remember rightly, if the compressor goes, the discharge goes over a certain temperature, the system will shut down as a protective measure. But the ram air controller, it's looking to see what temperature comes off the compressor. Yeah, and it's constantly adjusting the position of the door to allow the right amount of ram air across the heat exchanger to cool it down. From there, the air going across the secondary heat exchanger, and again there's another temperature sensor making sure that the air that's coming out the secondary heat exchanger is at the right temperature to allow it into the turbine side of the air cycle machine. Air cycle machine, as we said before, is turbines driving the compressor. Again, that's taking away all that temperature, and then the air is going to go through into the water separator. Again, as we mentioned before, on the water separator, we've got that little 35-degree switch or the 1.7-degree switch, whichever units you work in, it's the same thing. And all that's doing is adjusting the position of the bypass valve across the cold air unit. So if the temperature drops at the below 1.7 at the water separator, the sensor will talk to the valve, it'll open the valve up, and it'll allow more hot air to bypass the system to keep the temperature above freezing as it goes through the water separator. Water from the separator then goes through into the mixing chamber, where it mixes with the hot air from the the engine, and then that gets pumped into the cabin. In the cabin ducting, there's two temperature sensors. There's a 90-degree switch and a 120-degree switch. 90-degree switch, if we achieve that temperature, it'll trip the system off. Yeah. Once the system's cooled down on the control panel in the cabin, the pilot can podge a button and that will reset. And the system will set up and running again. Yeah. In case there's a failure with the 90-degree switch, there's a 120-degree switch, and again, if we achieve that temperature, it's going to trip the system off. Yeah, but the 90-degree switch is the primary protector. The other thing you'll notice, just prior to the mixing chamber, we're going to take a tapping of cold air. And that tapping of cold air runs off to the gaspers. And the gaspers are the little louvers that you get on your overhead panel that you turn off so you can direct cold air onto the passengers. Yeah. Turbofan we've already mentioned for tapping from the bleed air side of things. Yeah, and again, your controller, yeah, your auto or your manual, we can go cool, we can go warm, and the system will look after itself. The auto range, or if we turn the switch right the way around, we've got a hidden by the handle, but you can see the manual selection there. We select auto, we select towards the cool side of it. That mixing valve will look after, via the temperature regulator, the mixing valve will look after the system, and we can see what the temperature is like in the mixing valve. So if we need to adjust it, we can, yeah, and see what sort of temperature we've got coming out of the supply. This particular control panel, we can see what the temperature is like in the duct, so we know that we're not going to get an overheat in the ducting, or if we are, we've got a warning of a problem. Or we can look and see what the temperature is in the cabin. Yeah, and that's your dual gauge. It'll just give you the reading for whatever's selected. If we get an overheat, the system will trip off. You'll get a warning light to tell you that it's tripped off, and once the system has come back down to a usable temperature or below the trip off temperature, we can press the button and that will reset the system and it'll start running again. Yeah, and again, taken from the notes, yeah, just a picture of the valve, the control panel, and what each of the various selectors is doing on that. And just a coloured version of it for you. Yeah, so your pack control panel, different aircraft type. Yeah, the pack valves. Yeah, got your engine feed on for your bleed air. Again, we'll have a look at the bleed air side of it towards the end of the week. But we've got the bleed air. Switch the bleed air on. Yeah, and we'll go to the pack. The pack switch is either off, or it's automatic, or it's open. Can select it. That will then select and allow that hot air through into the system. Yeah. Condition of your bleed air. Yeah, whether your pack's on or off, tripped on or off. Whether the bleed air is on or off. Reset switch for the bleed air. Yeah, overheat warning light for your pack, and the recirculation side of it we'll again have a look at in a couple of minutes. Has anybody got any questions, any problems with any of that little lot? Anybody at all? No? Okay. Right, in that case, then, I think what we'll do we'll go and have a cup of tea. Yeah, I'll make that. Well, I'll make that 10:15, so we'll call it 10:35 my time. We'll have 20 minutes. Time to get away from the screen, grab a cup of tea. In Kathmandu, that's 1600, so we'll say 1620. Okay?
Okay.
Yeah.
All right, I'll see you in a few minutes then, guys.
Okay.
Mr. Jim,
Hello.
what are the highlighted part of this chapter?
Pretty much all of it.
All of it.
Yeah. Yeah. We need to know how the air cycle machine works. Need to know about the fact that it's got 2 heat exchangers. We need to know where the hot air is coming from.
Need to know anticipator.
Yeah, and the limit switch. Yeah, just what they're there for. Yeah, to stop those great big gushes of hot and cold air when we're changing.
So basically, the both sensor are doing the same job.
Yeah, what one's telling the regulator that it's going to need to get ready to change, and the other's just limiting the amount of temperature change you can have. So let's say you're at 20 degrees, yeah, and or you wanted 20 degrees and the cabin was at 18. Yeah, the anticipator would say to the regulator, right, we're going to change temperature in a minute, just be ready. And the limit switch is there to make sure that it doesn't overrun, doesn't get too hot too quickly.
One is monitoring, other is limiting.
Yeah. The anticipator's just telling the system to get ready. It's going to need to adjust. And the limit switch is just saying, right, well, if you want to reduce the temperature, you don't want to be putting a big blast of cold air in. Yeah, so it's just limiting the rate of change, if you like.
And those ram air temperature sensor, those are important. Which is
because
inlet.
Again, all that's doing is making sure that the door is allowing the right amount of cold air into the
inlet. Yeah.
Into the inlet. Yeah.
Into the heat exchanger.
Yeah. So we're not looking too deep into it, but we need to be aware of what the components are doing.
Hello, Jim.
Yeah, just give me 2 ticks.
Hello, Jim.
Yeah.
Can you give us those questions like the part 1 chapter for this chapter 2 also? That's why we can take a reference to study.
Yes. Yeah, I'll get those sent out. Yeah, I'll send them again like I did this morning. I'll send them to Yadav and he'll pass them on to you.
Okay. And these all are applicable to model 11, 12, 13, or it will differ from these different models?
No, these are all common, I think.
Common, and the question carries the same level or will differ?
The levels might differ. I can't remember what the levels were for. I don't think it's that much. I think it's level 2.
Okay.
I'd have to double check, but I don't think the levels are too high for you this section.
Because I am for model 12, and then model 13 also same level or different? That's my question.
For 11, it's level 3.
Yeah. For model 13, it's level 3, and for model 11 and 12.
12, I don't know. For 11 is level 3.
I think all of them level 3.
Okay.
Mechanical part goes to the level 2 for the 13, and then 11 and 12 goes to the 13 part is level 2. I think so.
Okay. Okay, thank you for the information.
That's okay. Sorry, I don't know the levels offhand. I haven't got the book in front of me. Who was asking me about the anticipator a
Question.
minute ago?
Yes.
We have
Is that Krishna?
The table that which goes to the which level, and then what kind of questions is coming on. I hope from you, because you are the questioner or examiner. So you have to have that things, and then if you distribute that one, very helpful for us. Then how can we concentrate with the topic? You got it?
Hang on, are you talking to me?
Yeah, I'm talking with you.
Yeah, sorry. What are you saying, Surrender? I couldn't hear you.
Yeah, just you are the examiner. Your AST is the examiner, and then you must know that which topic for which one. I'm the B2, and then only we are a few of person B2, the rest of other B1. So we need to know which category of the questions is coming on. For me, 11, 12, level 3, level 2, level 1. What going on that? The earlier instructor given that the for B2 this and for B1 this. So we can concentrate in our topic. So if you can provide that one, that is much better for us.
What levels that
the level of the questions, the B1 and B2 is not same category, So
okay, I'll have a look at that for you.
For me, that mechanical thing is very hard. Okay. So I must have the level low than B2 electrical part. Okay, in electrical part I'll get the maybe level 3. Doesn't matter. I can cover it, but let us know what level we are going to the. We have 18 books on this subject, so all included, all mechanical things, and then we are bit poor in mechanical things than electrical.
Okay, was it
personally? No, so if you provide us the classification level, what
Surendra sir,
we are getting.
Surendra sir,
yes,
मैले त्यो के भन्छ फेरि कन्भर्सेसनमा त्यो लिंक शेयर गरेको छु के त्यो इयासाको हो हैन त्योमा कुन लेभलको क्वेशन आउँछ त्यो लेखा छ है त.
Okay then. Okay, I got it, Mr. Campbell.
Okay then.
Mr.
You're happy now?
Yeah, I'm happy now. One of my friend shared it.
Mr. Jim.
Yeah.
Yeah, I have shared the IASA SS.
Say again.
Okay, Mr. Campbell.
I have shared the IASA rules where there is mention about the level of the question.
All right. Okay.
Okay, that's fine then.
So everybody's happy with that, are they?
Oh yeah. All right, Mr. Campbell. We can continue. Or
okay, I'll do that.
Yep.
Right, we've got everybody back.
Excuse me. Jim?
Yeah.
The cold air supply is all from the engine bleed air?
No, engine bleed is hot air.
No.
bleed air comes from the engines. Bleed air is very hot.
No,
So
no.
what we're doing with the system is we're cooling that hot air down.
Yeah.
So
So
we're
my
taking
question
the hot
is,
air from the engine,
yeah,
we're running it through the air cycle machine,
yeah.
and by putting it through the air cycle machine and the heat exchangers, we're taking all the temperature out of that hot engine air.
So my question is, what is the cold air supply of a environmental control system?
The cold air comes from the air cycle machine.
So
we start off with hot air, yeah? Hot air from the engine.
Yeah.
And that's all we've got. We've only got hot air from the engine. And what we do is we put that hot air through a heat exchanger. And that heat exchanger is using ram air from outside.
Yeah.
Yeah, it's blowing it across the heat exchanger, and that's taking some of the temperature away from that hot air.
So,
we're then going to put it into the
so
compressor. Sorry?
Yeah. So ram air is only passing through the primary and secondary heat exchanger. It is not the part of the system, right?
Yeah. It's coming from outside the aeroplane. We're blowing it across the heat exchangers, and that's all the ram air is there for. It's a bit like the radiator in your car, isn't it?
Yeah. So it's not the part of the air cycle machine.
No.
Okay, that was my question.
Right. Okay.
Thank you.
No problem. Anybody else got any questions?
Hello, Jim.
Hello.
Is this Gasper fan and then Luber, is it the same thing?
The Gasper fan, yeah. I'm going to come on to the Gaspers in a couple of minutes. If you just hold on.
Oh, okay. Thank you.
Yeah, we'll look at those in a minute.
Excuse me, sir.
Yes, sir.
In this diagram, we see the turbofan also in the exhaust side of the ram air. At what time the turbofan come in the command?
Say that again. Sorry.
So my question is, the turbofan is in the exhaust side of the ram air.
The turbofan, yeah.
Yes.
That's there for when the system's on the ground. If you haven't got any ram air flowing across the heat exchangers, you can't get rid of the heat from the engine air. So if we're on the ground, you haven't got ram air, the forward motion of the aircraft pulling ram air across. So what we do is we use that little turbofan to induce an airflow, to suck air across the heat exchangers.
It's controlled from the cockpit?
Yes, when you turn the shut-off valve on, yeah.
Okay, thank you, sir.
Anybody else? No? Okay then. Okay, so we have the control panel. Different control panels, different aircraft styles, but they're all giving us that same information. Do you make sure your mics are on mute, please? Thanks. On larger aircraft, what we can do with our air conditioning system is split the aircraft down into different areas, different zones, and we can have different temperatures in different zones for comfort. So if you imagine, so we've got an aeroplane, yeah, and we'll split the aircraft into three different zones. Yeah, let's say zone 1 is full of, I don't know, old people. Yeah, old people tend to feel the cold. Yeah, they get very cold very quickly. My mother is terrible. She's always got gloves and a coat on. She's always freezing cold. So if I put my mum on this aeroplane, yeah, I maybe want to keep her at let's say 24 degrees. Yeah. Young children, yeah, young children are full of energy and they don't feel the cold as much as old people. So maybe for one section of the aircraft, if we're full of young children, we might want to keep the temperature down a little bit. Yeah, so maybe at 21 degrees. Yeah. And then we've got, I don't know, let's say NAT students at the back. And NAT students, it's very difficult to keep them awake. Yeah, so what we need to do is to bring the temperature right down so they'll keep awake and concentrate on the studies. So we could reduce the temperature in that zone to a low level. We'll say 18 for 21 is a bit much. So what we can do is we can have different temperatures selected for different areas of the aircraft. It works in theory. In practice, it's not fantastically good. But treating those different areas and having the different temperatures in different areas is known as the trim air system. Yeah, and all we're doing with the trim air is just directing different temperatures to different areas. If we have the trim air system switched off, the whole cabin would be at a selected temperature. If I turn the trim air on, then I can adjust the temperature in different zones to suit the requirements. So I was talking about old folk, youngsters. It might be that you're carrying, I don't know, casualties. So you need to keep them warm, you know. So at the back of the aeroplane, we can adjust the temperature and we can crank that temperature up. So that's when they talk about trim air, that's what we're talking about. We're talking about taking a tapping of hot air and directing that selected air to different regions of the aeroplane. Yeah, your trim air system. Again, the trim air control. This is an old style control panel, but it gives you an idea of what's going on. We've got the selector. Let's just say zone 3, the back of the fuselage. Yeah, we can select what we want. We want it a bit cooler, so we select cool. Yeah, we can monitor the temperature that's going on. We're looking at a temperature gauge to see what the temperature is in that particular area of the passenger compartment, and we can adjust it as necessary. Again, if we get a problem, we've got a reset switch. Yeah, the selector for open and closed. Yeah. Again, I think this is a 737 control panel. Yeah, we've got the trim air selector, and we can adjust the where it says the control cabin, the control deck. Yeah, maybe the pilot gets a bit chilly, so he wants to be a bit warmer. He can switch his trim air in and select a bit warmer, hotter air directed to the cabin. Yeah, forward cabin, the aft cabin, we can have the same so long as the trim air is selected. Yeah, and again, just giving you an idea of the trim air. I don't think this picture's from the. Just see if it's from the notes. I don't think it is. Just, again, this particular example, we've got 3 cooling packs on the aircraft. Again, you can see your air cycle machines, your ram air with the deflector doors, the heat exchanger. What else can we see? The water separator. Once that conditioned air goes up to the distribution ducts, yeah, goes up. We've got trim air valves there now, so we can adjust the temperature of the air in a particular region of the aircraft, in a particular zone of the aircraft. I don't think there's much else to say on trim air. This is the diagram that we've got in the notes. It's not fantastic, but it gives you the idea. Yeah, we've got the controllers for the different areas, from the distribution packs, from the cooling packs. We've got that conditioned air coming in. Yeah, and what we can do is, by opening the trim air valves, we can introduce more warm air to increase the temperature or reduce the temperature of the air coming in. So we can alter the temperature in the different zones of the aeroplane. Again, your bleed air, conditioned air. The trim air is the mixed air. Yeah, to again allowing different temperatures in different regions of the aircraft. That's all that a trim air is. Yeah. Some of the more modern aircraft, you haven't got all this. It's controlled off the old telly screen by the cabin crew. Cabin crew of, they'll adjust the temperature from the flight attendant's position as they see fit. It doesn't necessarily have to come from the cockpit on the more modern aircraft. Again, distribution of that air, the engine bleed air, yeah, through the cooling packs into the mixer, yeah, and then a tapping of that hot air into what they call the hot air manifold. Yeah, from the mixing chamber, yeah, we can introduce more hot air if we want to, but that air is going to get pumped up into the distribution system, into the ducting. Pardon me. That conditioned air from whatever zone circulates round, yeah, and then it gets ducted via little louvers at floor level down into the cargo compartments, treats the cargo compartments, and from there it's going to get vented overboard. We'll look at recirculation in a couple of minutes, but that's how the air's distributed about. Yeah, from the mixer unit, we can adjust, we can add a little bit of hot air. If we have the trim system switched off, then the cabin is just going to go to the coolest selection that we've got. Again, just an example of a control panel. I don't even know what type of aircraft that is offhand. It's just showing that the engines are running. Yeah, and this particular control panel is looking at the various temperatures at the different locations. Yeah, so we've got 520 degrees Fahrenheit coming off the left engine. Yeah, right engine monitoring at 735 degrees Fahrenheit, which is pretty warm. Yeah, through your cooling packs, and you can see we're bringing that temperature right down. And then for the different areas, we can adjust the temperature. We can mix a bit of warm air in, and we can see what temperatures the different zones are running at. And again, controlled either from the flight attendant's position or the cabin, and it can all be adjusted, so we can keep the aircraft nice and comfortable and comfy and cozy. Everybody okay with that? Trim air. The air cycle machine, yeah. Now, something to remember, something to bear in mind. The air cycle machine will only work if it has got the heat exchanger between the compressor and the turbine. Yeah, the primary heat exchanger is taking the hot air, cooling it down initially. It's going up to the compressor. Yeah, as it says, it goes up into the compressor, gets squeezed together, that temperature gets raised, and then it goes through the secondary heat exchanger. You can see here the typical temperature values. Yeah, where coming from the primary heat exchanger, we've gone down to about 82 degrees. Through the compressor, that temperature is raised to about 140 degrees. And then through the secondary heat exchanger, we're taking an awful lot of that temperature away, down to about 50, 60 degrees here. Up into the turbine side of things, as that air goes into the turbine, it's expanded, the temperature drops. Yeah, and again, because we've got the turbine driving the compressor, converting any remaining heat energy into work energy, and the temperature coming off the turbine is around about 2 degrees C. So you can see from, what is it, 80 degrees in, we can bring the temperature right down to about 2 degrees going out. So it's a very efficient, very effective system. It does work well. What we've got to do is be careful that temperature coming off the turbine doesn't drop too much, and that's where that 1.7 degree switch comes in, or the 35 degree Fahrenheit switch. Yeah, it just allows a little bit of hot air to bypass the cold air unit or the air cycle machine to keep that air above freezing point as it goes into the water separator. Yeah, I wouldn't worry too much. It's just showing the ins and outs of the air cycle machine, yeah, and the different components going in. So you bleed air into the compressor, yeah, goes through the compressor, gets squeezed, temperature rises off to. Now the intercooler is just another name for the secondary heat exchanger. Don't worry about that. Yeah, if we talk about the secondary heat exchanger, that's all we need to know. Goes through there, gets cooled down, comes back in into the turbine, and then off to the mixer unit. And it's the turbine that drives the compressor. That is well worth remembering, guys. It's the turbine that drives the compressor. Everybody okay with that? Any questions there?
Jim,
Yeah.
turbine will drive from the electrically or pneumatically?
Pneumatically, it's the air going up onto the fan blades of the turbine that drives it round.
Sir, but the air go first to the compressor side.
It does, but it goes through the compressor.
Yes.
Yeah, but it's the air that's striking the turbine blades that generates the movement.
Okay. Then air goes through the compressor, it will drive the turbine, and turbine will drive the compressor.
No, the compressor is driven by the turbine.
And turbine will be driven by air.
Yeah, so as on an initial startup, yeah.
Yes, sir.
When
yes.
that bleed air goes into the compressor, yeah, it's not doing a great deal. It's just ducting through.
Okay. Yeah.
The air will flow through. Yeah, it'll come back up from the heat exchanger into the turbine side, and the size of the turbine blades are a lot bigger. Yeah. And the air passing across the turbine blades will start to drive that turbine round and round, and that turbine then is turning the compressor. Now, as that compressor's turning, the bleed air that goes in there is getting more and more compressed. Yeah.
Okay, I got it now, sir.
only on initial startup. Yeah.
Okay.
The air just drifts past the compressor, but as soon as it strikes the turbine, it's the turbine that starts turning the compressor.
Okay, thank you, sir.
Okay.
Yeah, thank you, Jim.
Anybody else? No. Right. The shaft for the turbine, the compressor, that common shaft, yeah, that runs on. Again, I wouldn't get too het up about the air bearings. Just got to let you know they exist. But the shaft runs in an air bearing, and the whole purpose of the air bearing is just to make sure that it's very, very smooth running, and that there's no friction there. Yeah. The bearing itself is just these little foil segments inside, and it just creates a cushion of air for the shaft to rotate on. Again, it's just to provide a friction-free flow. The heat exchangers that we talked about, the primary and the secondary heat exchangers, are just like, as we say, our car radiators. What we're going to do is pass hot air through a series of pipes, yeah, pass that hot air one way, and we're going to blow cold ram air across those pipes. And obviously, as the cold ram air flows across, it's taking the heat away from the bleed air. Again, if you see charge air and you see bleed air mentioned, they are both exactly the same thing. Just I think one's American terminology and the other's English. But charge air and bleed air, exactly the same thing. And the heat exchanger, all that's doing is taking cold ram air, blowing it across the pipes that contain the hot air. The hot air is giving up its heat and flowing on its way. Okay with that? Distribution, yeah. We've gone to all the trouble of treating that air. We need to make sure that it's circulated around the cabin, and we do that via the ducting in there. So behind the baggage stowage and down the center of the roof, there's ducts, and that conditioned air is blown into the cabin and it's circulated around. As it circulates around, yeah, it escapes from the passenger side of things via little mesh louvers at floor level. Yeah, and it gets ducted down behind the lining in the cargo compartment. And again, that conditioned air is going to condition the cargo compartment, keep that nice and warm. So whatever we might be carrying in there, be it, well, I don't know, flowers or horses or polar bears, whatever we're carrying, we can keep that in the right environmental condition as well. Okay there. Right, our water extractor. Yeah, and there are two types of water extractor. We'll look at the other one as part of another system. But the common type of water extractor that we'll come across in this system is a metal framework, metal container. We've got what they call a coalescer. The coalescer is just a cloth sock that fits over well, it calls it coalescer support. Let's just see if we've got a better picture. Yeah, the coalescer support is just with a cloth bag around it. As the air comes through from the turbine side of things, it's 1.7 degrees C, 35 degrees Fahrenheit. That cold air is going to flow into the water extractor, and it's going to get pushed through the the coalescer sock, and that coalescer sock is it's just like a felt material. Yeah. And what happens is as the air is forced through that sock, yeah, it goes through a series of little slots in the support for the sock. As the water, as the air passes through, the very, very tiny droplets of moisture that are in there get trapped on that felt sock, and they turn into bigger particles of water. And as the air is going through, yeah, it pushes those larger particles of water through the little slots and into a collecting chamber. So that the air is pushed through the water as it goes through the slots. It's caused to swirl, and as that water swirls, centrifugal force throws it out the way to the sides of the collection chamber, where it'll dribble down the sides and go off to a drain, or as we said, we can go off to the ram air inlet, where it'll get sprayed on the face of the water extractor, the heat exchanger. Yeah. So that's all that's happening with the water extractor. The air is going through, it's being pushed through this felt type material. The water droplets is forced through these little slots in the support. The air is caused to swirl, centrifugal force throws out the water droplets to the side of the collecting chamber, and then we'll take away that excess water and use it elsewhere in the city. Should this sock become clogged for any reason, and they do get filthy, they get serviced from time to time, they can get very manky, but should it get blocked, there's a relief valve in there, a bypass valve. As the air struggles to get through the sock, pressure is going to build up. That pressure building up is just going to open the bypass valve, and the air can then just flow straight through unfiltered. So really, your water extractor, it's taking the water out, but it's just a posh filter. Yeah. There's a indicator on there just to tell you whether the bag is clogged or not, and it's just like a reservoir indicator, just a little popper. If the end cap pops out, it tells you that the thing's blocked. And there we go. That's where it sits like your temperature sensor. Yeah, the air coming in, blown across this this sock, allowed to go on its merry way, and then there's a collection chamber for excess water. That's what the thing looks like in reality. Yeah, that's your cold air unit, your heat exchangers. Yeah, from your heat exchangers. That's the little bypass that we talked about. So the 35-degree switch, talking to the bypass valve, maintains the temperature 1.7 degrees into the water separator, water extractor. Yeah, the water's separated by centrifugal force, and then it's drained off to get used elsewhere. Everybody okay with that? Any questions? Any questions there? Yeah, all very quiet.
All good.
All good, I heard through the grapevine. Right, the ducting that we're going to use for our system, obviously the material the ducting is going to be made out of depends whereabouts in the system it is. Once that air's been conditioned, once it's been cooled down, we can use our light alloys, light aluminium alloys, plastics or reinforced plastics for the distribution ductwork. Yeah, it's not hot. It's not going to be affected by temperature. If we're in the hot air region, we're going to use stainless steel or titanium. Normally stainless steel pipework though. V-band clamps. I'm sure you've all come across V-bands, absolutely awful bits of kit. What I would say with these systems is if you fit in the V-bands, make sure that they're fitted properly and follow the procedure for them. Because if you haven't fitted the V-band properly, you can get hot air leaking, and hot air leaks can be exceptionally dangerous to the aircraft. I speak through experience. We've had a couple of aeroplanes, V-bands not fitted properly, and the rear end of the aeroplane caught fire. So not a very nice experience for the pilot. The expanding couplings are there in the system just to allow for expansion and contraction. As the hot air's flowing, the pipes are obviously going to expand. As the system cools down, they're going to contract. So the expanding couplings just allow for expansion, contraction. So we've said that we're going to pump all this air around. We're going to circulate all this air within the cabin. But as you know yourselves, sometimes it can be too warm for the individual person. So what we're going to do is take a tapping of cold air and run that up to the passenger service units, the air conditioning panels above the seats. Yeah, that cold air, that cold trim air, goes through a little fan. The little fan pulling the cold air through and directing it up to the PSU, the passenger service unit, where we can adjust the little louver, the little twisty thing, and that'll direct cold air down onto the individual passenger. You've probably done it yourselves. It's great fun if you direct those little vents onto the person that's sitting next to the window and they can't move and they're getting all this cold air blowing on them. You shouldn't do it really, but it's good fun. The little gasper fan, is there to induce that cold air into the PSU, into the passenger service unit. Yeah, and again, via your ducting, it'll go to the individual seat panels. From there as well, we've got the adjustable air. It's just the little twist louvers that allow that cold air to blow down onto the individual passengers. And again, as we mentioned before, the floor exhaust, from the cabin, and that air, that conditioned air, is going to be directed away and down into the cargo compartment. Yeah, those are the things I'm on about. The passenger service unit, where you've got your call button for the stewardess, or the cabin crew, I should say. Yeah, you've got your light switch on there. And you've got these little individual louvers, which are just a pull, twist, and as you pull and twist, it opens the wee shut-off valve, and that allows cold air. And obviously, you can swivel these things to direct that cold air to wherever you want it to be. Anybody got any questions on any of that?
Yes, I have.
You have, yes, sir.
The V bands, are they torque loaded, or how they are tightened? The V bands, earlier you talked.
The V bands are torque loaded, yes.
And are they locking wires being done or not to that?
Some of them, not all of them.
Okay, but torque loading is done.
Yes, yeah. I'll try and dig out a picture. Have you come across V bands? Do you know what they look like?
Yeah.
Yeah. Well, the stiff nut that goes on the V band clamp is torque loaded.
Okay.
But sometimes, depending on whereabouts in the system the V band is, sometimes you might wire lock the two halves of the clamp together.
Okay.
Okay, that's anybody else? Okay. Right.
Hello. Hello.
Hello.
Jim.
Yeah.
There is one line in our notebook: to permit longitudinal movement of docking as it expands and contracts, expansion bellows, sliding clamps, and gimbal mountings are provided. What is this gimbal mountings?
The gimbal, it just allows for a slight movement within the pipe work. I don't even know how to draw one really. The best way to describe, you see the ball affair here. Can you see on the slide, Prakash?
Yeah. Yes. I'm seeing that.
Right, lovely. Well, your gimbal is similar in as much as you've got your pipe ducting. Yeah, and that pipe ducting will fit to a kind of, I'd say bearing, but bearing's not quite the right word. But that gimbal rotates. It allows the pipes to move slightly. So as they're expanding and contracting, that gimbal just allows them to move. That's all the gimbal is. The bellows just allow expansion and contraction. So your bellows are kind of that shape. Yeah. So as the pipe heats up, those bellows will expand slightly. Yeah. And as the thing moves down, the bellows will contract. So it just it allows for movement of the pipework, so it doesn't cause any damage when it's expanding and contracting.
Okay, Jim. Thank you.
That's okay. Anybody else? Oh. Right. So next bit then is humidity control. Where we've run the air through the system, we've taken all the moisture out. Again, to prevent freezing, to prevent particles of ice being flown through the system, prevent blockage, all the rest of it. But if we took all the moisture out of the air, it would be exceptionally uncomfortable for the passengers. We need a certain amount of humidity for comfort. If we didn't have that, your eyes would dry out, your nose would dry out, your mouth would dry out. You'd be really, really uncomfortable, and it can get very, very painful. So what we need to do is to reintroduce humidity back into the conditioned air. So again, what we'll do once the air has been through the water extractor, through the cycle machine, once it's nice and mixed, prior to it going into the cabin, we'll reintroduce that moisture. And we just do that via a little humidity controller, normally automatic. It does say you can have it manual, but they're normally automatic. And what it is, it's a little tapping from the potable water supply, and that little tapping is pushed up into the bleed air pipe, the charge air pipe, the air that's going into the cabin. Just behind that, a little bit of bleed air spraying onto the water. The bleed air hitting the water vaporizes it, atomizes it, and pushes that moisture back into the air. Not a lot else I can really say about that. Yeah, I guess most aircraft we're just going to take the galley water. Yeah, just take a small tapping of that, run it up into the conditioned air ductwork just behind that tapping. A little bit of bleed air just to cause the water to atomize, to vaporize, and it just puts the humidity back into the air. I'll just double check. I think you maintain it around about 30 to 70 degrees humidity for comfort.
It's 30 degree.
Sorry, just double checking. I don't want to give anybody bad information. So around about 30% humidity.
30%, yeah. Page number 28.
Yeah, like I say, you know, nice and it just gives comfort back. Again, just to give us an idea, we've got air flowing through, goes through the water extractor. This one is showing the air that's come from the water separator being reused. Normally, we would take it from the potable water supply, but that water separator, as the air's caused to swirl, it runs down to a wee drain, yeah, into a collector tank. Yeah, don't worry about that. And then from the collector tank, we've got a little pump, yeah, a humidity control unit. So the air, moisture taken out of it, the air carries on its merry way, and then it's reintroduced further down in the duct via the wee spray nozzle. Yeah, so we just introduce that air back into the thing. And we can control the amount of moisture in the air. Then we can control the humidity in the aircraft. Everybody okay with that? Any questions there? So just give me 30 seconds. I'm just going to have a quick look and make sure that I've not missed anything. I don't think I have. Turn it off. Okay, lovely. Pretty sure I've covered all that. What time do we start back? Right, been going at about an hour there, guys. I think we'll just have 5 minutes, get away from the screen, stretch our legs, just blink your eyes. Are you guys happy with a 5-minute break, or do you want a bit longer?
10 minutes will be better.
10 minutes. Okay, we'll have a 10-minute break there. Let me check Kathmandu time. Kathmandu, it's 17:10, so 17:20. Okay?
Okay.
Right, we'll have 10 minutes there.
Sir, go ahead, sir.
Okay, see you 10.
खगेन्द्र सर
हजुर
मैले तपाईले पठाएको छु नि एकचोटि चेक गर्नु न
ल म भाइबरमा कल गर्छु तपाईलाई है त एकैछिन ल
ल
Oh, yeah. Okay.
Jim,
Yeah.
I have a question from the question bank. I want to ask you.
Yeah, go on.
The cold air supply of a helicopter environment control system is generally, and the option is bleed air from a turbine engine, and option 2 is ram air from external scoops.
And what was the question again?
The cold air supply of a helicopter environmental control system is generally. Yeah, and the options are bleed air from a turbine engine, and the second is ram air from external scoops.
It depends on the helicopter, doesn't it?
But generally, what will be the answer?
Generally, ram air.
But ram air is the supply or not? This is not the part of the environmental control system.
Well, if you think about we're going to cover helicopters in a little while. We'll do helicopters, but if you think about a helicopter, what's the best way to get conditioned air? Open the window.
Yeah.
Yeah.
Yeah. So it will be simply ram air from external scoops.
Generally, yeah. But I mean, there are helicopters that use bleed air for conditioning.
Yeah.
So it's a bit of an iffy question, I'd say.
So if it is generally, then we should say ram air from external scoops.
Yeah, if it's a smaller aircraft, yeah.
Okay. Okay then.
You know, certainly for things like ventilation, yeah, it's going to be. But if you get a larger type of helicopter, you know, NH60 or whatever, that's going to take bleed air from the engines to give you your conditioning.
No, it's simply the cold air supply. It's asking for the cold air supply.
Yeah, that's from ram air. Yeah. Sorry, I misheard the question.
Okay, thank you.
Okay.
Yeah.
Everybody back? Anybody else got any questions before we kick on? Right.
Yes, Jim.
The next.
No, sir.
Yeah,
I have
go
some
on.
question. Yeah, when we go through the content in a book, we found like the power supply to the pack valves and how the pack valves are operated. Some are operated pneumatically and electrically controlled. Some are electrically operated and pneumatically controlled. Do you need to remember all these things in accordance to the exam point of view?
No, you need to know what the pack valve is. Well, you know, it's the on-off switch for the packs, but actually how it operates, no.
Okay, thank you so much.
Yeah, well, what you've got to remember with these notes are written for guys that have never seen an aircraft, never worked on an aircraft before. Yeah. So that these are the training notes, giving them all the information they need. Yeah. So the actual, for exam purposes, the actual internal workings of the valves, we don't need to worry too much about.
Okay. Thank you so much.
Okay. Anybody else? Right, the three-wheel cycle machine. Yeah. What we get with the three-wheel cycle machine, remember we we looked at the ram air before, and we looked at the we had a little fan in the turbo fan in the ram air duct. What we do with the three-wheel air cycle machine is, rather than having a fan in the duct, we're going to put a fan on the end of the common shaft of the air cycle machine, and that fan is going to do exactly the same job. It's going to induce an airflow, induce a ram airflow across the heat exchangers. So all the three-wheel air cycle machine is the turbine, the compressor, and on the end of that common shaft, we've extended that shaft and we've put a fan on there, and that fan sits in the ram air ducting, and it pulls the flow of air through the ram air duct. Generally, no, not saying all the time, but generally, the three-wheel air cycle machine is found on helicopters. When you think about a helicopter operating, it's going to be in the hover for a lot of time. You haven't got that forward cycle machines operating, then we're going to be inducing a flow across the heat exchangers. Larger fixed-wing aircraft use the three-wheel air cycle machine more for when the aircraft is sitting on the ground. So it replaces the pardon me, replaces the fan in the ducting that's operated by the APU. But I'd say more generally, you'll come across it on a rotary wing aircraft. So again, yeah, you've got exactly the same layout. You've got your ram air ducting, you've got your deflector door, operated by a little motor, regulating the amount of ram air that's coming in. That ram air flowing over your heat exchangers, yeah, and then off to exhaust, yeah. Your pack control, yeah, your hot air coming into the system, yeah, again through your primary heat exchanger, through to the compressor, yeah, through your compressor, from your air compressor, forget about the reheaters for the time being, into your turbine, yeah, your turbine off to your sort of mixing chamber. In this case, we're using a heater and a condenser for our moisture control, and again, that moisture that we remove, we're introducing back into the ram air supply just to make the thing more efficient. But when we're talking about the three-wheel air cycle machine, that's the bit we're concentrating on. That's the bit we need to worry about. Yeah, the fact that we've got the fan on the extended shaft of the ACM. Yeah, and again, simplified system. Yeah, ram air coming through, air cycle machine. Yeah, with the extended shaft, and we've got that fan pulling air through, pulling air across the heat exchangers, and off we go. Yeah, your hot air coming in from the pack through the primary heat exchanger, through the compressor, through the secondary heat exchanger, into the turbine, and off we go. That's your three-wheel air cycle machine. Yeah, it's the extended shaft with a fan placed in the ram air duct, and the idea is to induce a ram air flow across the heat exchangers. Yeah. Other bit to remember, and it does come up as a question, yeah, the air cycle machine cannot function without the heat exchangers between the compressor and the turbine. Okay with that? We looked at a version of a water extract. Yeah?
Can you repeat again the last sentence you spoke?
Yeah, for for an air cycle machine to work, yeah, it has to have a heat exchanger between the compressor and the turbine. So the air that's flowing has got to go through that secondary heat exchanger.
Okay, thank you.
Okay. Right, where we go from there? Yeah, we talked before. We were chatting about the water extractor before. Another type of water extractor, the water separator that's mentioned, works on, but we don't have to dick about with the sock or anything of that nature. Yeah, all we've got is the bleed air or the conditioned air, I should say, coming into the water separator, and that air hits a series of vanes. As it hits the vanes, it's caused to swirl. And as the air starts swirling, any moisture that's contained within it, again due to centrifugal force, is thrown out to the sides of the thing. Within the water separator, there's a little mesh, yeah, and the water that's thrown out goes through the mesh and it goes into a sort of collecting area. Dribbles down the sides and into into a collector where it gets drained off. Coloured picture of the thing, yeah, just a bit, hopefully a bit clearer. Yeah, the air comes through, hits those vanes, swirls around, centrifugal force, throws the moisture to either side. That moisture dribbles down the sides of the body of the water separator into a collecting area where it's drained off to be either reused or to an overboard vent. Recirculation, yeah. Sitting in the aeroplane, yeah, the got pressurized air.
Excuse me.
Yeah.
Can you go back? The scavenge air connection, what is function? The main supply?
Yeah, don't worry about the scavenged air. It's just any air that doesn't pass through. Where the air's forced to swirl and the moisture comes through, there will be a little bit of air carried into that chamber, and that little bit of excess air is just taken away via the scavenge connection. Don't worry about it.
Okay, thank you.
Okay, you sure?
Yes.
Hello, Jim.
Hello?
Hello. Can you please again explain condenser and mixer?
The condenser
and mixer.
Those two.
Sorry. Condenser and condenser and reheater.
Yeah, don't worry about those. They're not mentioned in the notes. Yeah.
In the notes, there is conditioner and mixer. Page number 31. Condenser and mixer.
That figure, I don't have that on my presentation. But, what we're doing with the air, yeah, as we're taking the air out, we need to reintroduce it. And what we're doing with the condenser, yeah, is just making sure that the air, any moisture that's in the air, is converted into a liquid. Yeah, that's what the condenser's doing. It's bringing the moisture down into the liquid stage.
Okay.
Yeah, but like I said, with the three-wheeled air cycle machine, don't get too bogged down with the other components. what we're looking at is the fact that the fan is on the end of the extended shaft.
Okay.
Okay. It's like the slide that's on the presentation there. Yeah. We're taking the air from the turbine. Yeah. What we've done is heated that air up. We're making sure that we've got that's the best way to put it. What we're doing is vaporizing that air. Yeah, to make sure that there's no liquid in as it goes into the turbine. As it goes into the turbine, yeah, we're then going to condense that moisture again. Yeah, so we can remove it. The reason for that is if you put a liquid into the turbine's spinning that quickly. And it's very, very, how should we say, try to think of the right word. It's very, very, very tight area. As the turbine's spinning, if you get liquid in there, it could damage the internal workings of the turbine. So if we've just got air going through, just got gas going through, it's not a problem. Yeah. We're not. I'm trying to think of the right way to describe it. Basically, we don't want moisture. We don't want liquid going through the turbine. If we put liquid in the turbine, it would damage it. So what we're doing on this particular setup is we're taking the hot air from the compressor, yeah, running it through the heat exchanger, which is all that is, yeah. That's taking some of the heat away, but it's making sure that any moisture is completely gas. So that gas now is going to go into the turbine. As the gas comes out of the turbine, it's going to run back through the condenser. That's where it's going to get converted into liquid, and that's where the liquid will be removed by the water extractors and pushed back into the duct. Yeah, like I said, I don't want to get too bogged down in it because we don't need to worry about it. Don't need to know about it per se.
Okay.
Has that answered your question?
Yes, Jim. Yes, Jim. Thank you.
Okay.
So you don't want water to enter in turbine, so there is a reheater.
In this particular system, yeah.
Because the water, the water can damage the turbine.
Yes.
Okay.
Pretty much.
Thank you, Jim. Thank you, Jim.
Yeah. Right, recirculation then. Yeah, the air that we push into the cabin, we're using it for conditioning, we're using it for pressurization. Yeah, so the engines are using, particularly at takeoff, they're using an awful lot of power. Yeah, once we're up in the air, we want to reduce the power that the engines are using. So rather than having the engines pumping fresh air constantly into the cabin, what we can do is reuse some of the air that's been put in, draw air back from the cabin, remix it, and push it back in, and that's what your recirculation's about, really. So cabin conditioned, pressurized, 100% fresh air. There's a loss of power, particularly at takeoff. Fuel consumption, obviously, because the engine's working hard, fuel consumption is going to go up. So a recirc system consists of left and right units with your unrecirculation fans, filters, ducts, all the rest of it. The recirculation fan is pulling air back from the cabin. It's just a little fan, pulls air back from the cabin through a filter and puts the air back into the the mixing chamber, the mixing manifold. We then mix that air up with fresh conditioned air and push it on back into the cabin. It's dead easy, dead simple, and with the filtration we've got pretty safe. So that's all your recirculation fan is. Yeah, just a little axial fan. Put it in the ducting, yeah, and it just pulls some of that conditioned air back from the cabin. Yeah, puts it into the mixing chamber where it's caused to swirl. It mixes all up with the fresh air, and then we push it back into the cabin. The percentages for your recirculation: 60% fresh air, 40% recirculated air, mixed together, push back into the cabin, and that fan is constantly drawing air back through, yeah, filtering it and recirculating it. Dead easy system, dead simple, and it's there to just preserve the engines and save fuel. Really, that's what your recirculation's about. Obviously, with all the people that we've got sitting in the cabin, famous last words because of COVID and avian flu. But what we want to do is the air that people are breathing in and out, we want to make sure that it's filtered properly. So as the air is pulled back from the cabin, we're going to run it through filters. Yeah. Again, the filtration levels, don't worry too much about those. All we're doing is making sure that we take out as much rubbish from the air as is possible. So any dust, any small particles, even down to sort of virus type levels. Yeah, we try and filter it out, and the diagram's just telling us the different methods of filtration that we use. Yeah, I'm sure you've all changed the filters. They get absolutely filthy, like any filter, and all we're doing is pulling air through the filter, and any particles in the air are getting trapped and being taken out of the air, so that the air that's being pushed back into the cabin is pretty clean. Yeah, that's the sort of thing. Obviously, the filters are different sizes depending whether you're using them. That's the one from the 777. Yeah, and the air as the air passes over, it's just going through the actual filter, and that filter is trapping all your different particles. Everybody all right with that?
Where is the recirculating fan located?
They're in the cabin. The ones I've said, certainly the one on the jet streams up on the front forward bulkhead. Yeah, but the location of the fans can depend on the aircraft type. Yeah.
Okay.
Yeah, your recirc fans, well, you know, they could be positioned anywhere in the cabin really. You could have more than one. Yeah, and just pulling air back into a duct that takes it back to the mixing chamber after it's been filtered. Other component that we might get, that we might find in the system, is ozone converter. Ozone is a naturally occurring gas in the atmosphere, but high concentration of ozone are pretty bad for us. They're not good for our health. So what we need to do is, because it's aviation, because it's belt and braces, we'll put an ozone converter into the system. The ozone converter just takes the air from the engine, the bleed air. We run it through the converter. We just pass it over an element of some description. I think it's palladium, so it's something like that. and as the air passes over the palladium, it converts into oxygen. And obviously, once it's oxygen, it's quite useful. We can just allow it to carry on its merry way. Most of the ozone is dissipated, depleted naturally. Is that somebody pinging me? Yeah, palladium. I was right. Converts the ozone to oxygen, and away we go. Well, once that ozone's converted, it's not going to do us any harm. Yeah, the modern converters, they've got a life of around about 12,000 hours, and they are capable of converting up to 95% of the ozone that enters them. Yeah, so if you remember about 12,000 hours, the life of an ozone converter, they're very, very efficient, very effective, and they'll carry on going. And again, just a schematic of a three-wheel air cycle machine. Yeah, ram air inlet, the yellow piping, the extended shaft with the fan that's running, pulling the air over the air cycle machine, the heat exchangers that we need, the primary and the secondary heat exchangers. Anything else we need to worry about? No, your recirculation fan, yeah, that's going to pull air back from the cabin. Yeah, the recirculation system can either be automatic or it's got an on-off switch. It can be selected by the flight crew. We saw that on the control panel earlier. Temperature controller, we talked about that. The temperature selector. Your condenser, bringing your moisture back so we can run it through the heat exchanger. Yeah, so just example of a three-wheel air cycle machine system. And that was our turbine aircraft, your bleed air type system. I've got somebody in there. Somebody in the lobby. Shalendra.
Everybody here.
Everybody
I'm here.
here.
Surrender here. No worry.
Excellent. Right, so long as we've got everyone. Right, just the last little bit that takes us up to lunchtime. The displacement blower system, normally used on turboprop aircraft. All the ones that I've come across have been turboprop aircraft. Yeah, the displacement blower, the system is similar. Yeah, but what we're doing with the displacement blower is we're taking ram air in from the external source. We've got a blower that pulls that air in, pushes the air on through a series of ductwork down to our air cycle machine with the heat exchangers. That air, as it's pushed down the ductwork, it compresses, and because it compresses, it heats up. Yeah, because it heats up, that's where we get the temperature from. I mean, exactly the same as with. Oh, sorry, excuse me a minute. Exactly the same as we've seen before. We can then condition that air to push it on into the cabin. What we're doing then, we take the blower, run the air through a filtered inlet, through the blower. I'll show you that in a bit more detail in a moment, and down into the pipe work, through a silencer, and all that is the name suggests, it just dulls out the noise of the air rushing through the pipes. Through a check valve to make sure that it only flows in one direction. Yeah. Through a mass flow controller, that is just regulating the amount of air that we're going to allow into the system. And then what they call the heating choke. The heating choke is just a flap. As we increase the resistance to the flow of the air going through, the pressure increases, so the temperature increases. Yeah, so by using the choke, we can increase or decrease the temperature of the air flowing through that. From that point, the air is going to flow through a heat exchanger or bypass a heat exchanger down to a temperature control valve. That control valve is just a couple of butterfly valves that will open or close depending on the amount of temperature that we want. And opening and closing those butterfly valves is just forcing the air to flow in a required direction. So if we want hot air, yeah, we can close off this flap on the controller. It just means that the hot air is going to flow straight through to the cabin. If we want cooler air, yeah, we can shut off part of that flap. We can start to close that flap. And again, by doing that, we're forcing air through the air cycle machine. Yeah, so that as you'll see in the notes, the positioning of the temperature control valve is going to force the air in a particular direction, depending on what we want to do with that air. Let's say we've got the TCV, we want to go fully cold. Yeah, so we'll select fully cold. This, I'll do it with a pen. This part of the temperature control valve will close off. So now your hot air, or you can't go anywhere. So that hot air is going to be forced down through the primary heat exchanger. That's going to take away some of the temperature. Depending on how cold we want that air, we can again with our selector, let's say we'll partially close the TCV there. That's going to force some of the air through the cold air unit, through the second heat exchanger, through the turbine, water separator, into the cabin. Yeah. If I don't want the air too cold, I'll have the TCV open there. So path of least resistance, the bulk of the air is going to go through the primary heat exchanger, through the temperature control valve, and off to the cabin. Yeah, the water separator is going to work in exactly the same way as we saw before. No problem there. And I'll come on to the flow controllers on that in a minute. Yeah, the displacement blower is just a series of lobes. Air gets drawn in. Yeah, it's filtered as it comes in. These lobes are rotating, driven by the engine. And as they're rotating, they're pushing the air through into the ducting. As it goes into the ducting, it goes through the silencer, and all the silencer's doing is damping out the noise of the air going through the ducting. And we do that just by directing the air through a series of little perforated it's like a perforated tube. Yeah, and as the air strikes these little resonators, they absorb the sound. And that's all that's doing, is reducing the noise of the air flowing. Because we've got two engines running, we've got two displacement blowers, and these blowers are very, very efficient. We're going to provide far more air than we actually require for the system. So what we need to do is to control the mass of air that's being allowed down the pipework. And we do that by using what they call the spill valve. And the spill valve is operated by a flow controller. The flow controller is just looking at pressure and flow in the ducting. Yeah, so what it's doing is taking a tapping from the duct and directing that up to the controller and looking at the pressure in a venturi. The little venturi, yeah, again, we'll show you that. So within the ducting, we've got what they call a metering head, the venturi. Obviously, as air flows through, the airflow speeds up, the pressure drops. Yeah, so we've got a duct pressure and a venturi pressure. And they are acting on either side of a diaphragm. So your metering head, your venturi pressure acted on top of a diaphragm, the duct pressure acting on the lower surface of the diaphragm. Obviously, as the pressures change, yeah, the more flow that goes through that venturi, the faster, the more the pressure is going to drop. So as the pressure drops, the duct pressure acting on the lower surface of the diaphragm is going to cause it to raise. As it does, there's a little sort of plunger inside. As the diaphragm moves up the way, it pulls a contact up. As that contact makes, via a relay, it operates the spill valve. The spill valve will open. Yeah, so now the air that's flowing through the duct will just be dumped overboard. Obviously, the pressure going through the venturi is going to decrease. The duct pressure is going to decrease. So that diaphragm is going to lower. As it lowers, yeah, again, the contacts are going to break. So the spill valve is going to go towards its closed position. So this little spill valve is constantly modulating and regulating the amount of air that's in the duct. Yeah, so that's what your controller is. It's just opening and closing a valve. Yeah, not a lot else I can say about that. We don't need to worry too much about the internal workings. We just need to know that the mass flow controller is looking at the amount of air that's flowing through the ductwork, and it's operating the spill valve. The spill valve just opens to atmosphere and allows any excess to be dumped overboard. Yeah, so again, just taken from the notes, the blower capable of maintaining air conditioning pressurization at cruising altitude. Both blowers operating normally will get far too much air, so the excess needs to be dumped. Excess air spilled off by opening and closing the spill valve. Spill valves electrically operated, yeah, normally automatic, does it all automatically. There is a warning light in the cabin. If the duct pressure gets too much, then the pilot can open the spill valve manually. Again, temperature control from a control panel in the cabin. Because he's got his increase decrease switch. Yeah, that can operate in auto or manual, exactly the same as we had before. We can select maximum cold if we want, which directs everything through the cold air unit. Yeah, there are sensors in the duct to monitor the temperature. Obviously, if the temperature gets too high, we can open the spill valve. That'll dump out any excess pressure. If we take away that pressure, then the temperature will come down. But the duct sensors will put on warning lights in the cabin just to let him know. Pressure sensors in there, just to make sure that we don't overpressurize. If we get a blockage for whatever reason, a bird, small child, polar bear. And then there is the ability to just allow ram air into the cabin. So if, for example, a cabin filled with smoke, yeah, we could open the dump valve, that would evict all the air from the cabin, and would just use ram air to ventilate. And again, we've got the ability to have the air circulating on the ground. Again, with a fan in the ram air duct, we'll just turn that on. That will run, and that will allow the air to circulate while we're sitting stationary on the ground. Again, just example of your control, your auto, your manual, spill valve, whether it's open, it's closed. That would normally be modulating. We've got a manual reversion if we need to for the left hand and the right hand side. So we can your conditioning, automatic, normal, or we can select maximum cold if we want to. And then there's just a sliding shut-off valve that will open the cabin to atmosphere and open the ram air scoops to allow fresh ram air into the cabin. And again, that's just what we've already seen. So your inlet, the spill valve we've talked about to dump off the excess, the silencer keep us quiet, non-return valve making sure we go one way only, that metering head, the flow controller talking the spill valve, so the metering duct monitoring the pressures in the ducting, flow control regulate the flow of the air, pressure relief valve that will open if we get too much pressure in the duct, pressure warning sensor, if the pressure gets too high. The heating choke, as I said, is just a little open and close flap to increase the temperature. And then the temperature control valve, depending on the position, is going to direct the air through the air cycle machine, through the heat exchangers. Water separator, exactly the same as we've talked about before. Has anybody got any questions on any of that? No. Right, I think then that's 12:15 my time, so that will be 1800 your time.
Yes.
Yeah. So we'll say 1900.
Okay. All right.
Okay.
Is that okay with you guys?
Yeah. Okay.
Yeah. So we'll go and have a bite to eat, and then we'll get finished off. So we're back at 1900.
Okay.
Okay.
No problem.
Okay. See you in a few minutes then, guys.
Okay, Jim. See you after an hour.
Yeah, I'll see you in 1 hour.
Ram.
Nice. Hello, everybody. Have we got
Everybody
everybody
should
back?
switch off their mic.
Everybody hear me?
Yes, Jim, but not clear.
Milan, you've got your hand up. Right, guys, got everybody back. You can all hear me, and hopefully you should be all seeing the presentation saying equipment cooling systems, which we kind of had a look at yesterday when we were talking about ventilation. Yeah, with our equipment, certainly the avionics side of things, there's going to be a lot of heat generated, so we need to make sure that we we keep that equipment cool. So for our cooling then, yeah, all the B2 stuff, yeah, all the wires, going to keep everything very toasty. So what we're going to do, we're going to check some of the cabin conditioning of the cabin air, and we're going to duct that through the equipment base just to keep the cooling ventilation going. Yeah. What we can do is use little fans to draw the air through. Yeah, so the main cabin with little fans, we can blow the air around the back of the consoles in the cabin. Take that air down into the equipment base, the E racks, yeah, and make sure that the warm air is constantly refreshed, ventilated, and taken away, cooled down. If you get a failure of cooling, as we said yesterday, you'll get a warning horn sounding, so we know that things are getting too hot. I'm not sure who's got the microphone on. Could you turn your mic off, please?
माइक अफ गर्नु है कसको माइक अन छ त्यो अफ गरिदिनु त प्लिज
Chiranjeevi sir, mic off. Okay.
That's a bit better. I can hear myself think now. Right, everybody okay with equipment cooling then? Yeah, we're just going to use some of the cabin conditioned air. We're going to blow it around the equipment and vent that used air away overboard. Just make sure everything's kept nice and cool. And what I should have asked before we started off, as you say in the slide, has anybody got any questions about anything that we've covered so far?
The spill valve operation.
Yeah.
Through the mass airflow, that diagram.
Well, that one or the valve itself? That one?
Yes, this one.
Right, okay. You want me to go through it again? Is that what you're saying? Not talking to me. Do you need me to go through it again?
Yeah, this one, yeah.
Yeah, okay, right. In the ducting, yeah, we've got the blower, and that blower is pulling air in and directing it into the ductwork, the pipe work for the system. The amount of air that's being drawn into the system is far in excess of what we need.
Jim,
Yeah?
excuse me. The diagram is not coming to me. Only your picture is coming. Diagram is not here. Is there any wrong from there? On my screen, only your picture is coming.
What are you seeing now?
Your picture is coming, but diagram is not showing to me.
Actually, Mr. Campbell,
yeah,
pictures are not updated in our book. Whatever we are looking our book, some pictures are not there. Maybe not updated, or I don't know. Then we are following the book because you're just giving some lines, and then we have to read this book, and then if we not find that picture or that things, and then we'll have confused.
Unless it's been removed from the notes, but it's certainly in my book.
And please update it your book and then give it to the Sanjeev or someone in the NAT. Then we can get the correct book, because lot of things I want to say already, but Islam are watching. Lot of picture, what you are showing for us, that not appear in our book.
No, not everything's in the book, because what I've done, I've taken some slides and to make the presentation better, to make it more understandable, I've used different pictures from different places for the presentation. But certainly the picture that's on the presentation now with the spill valve and the mass flow controller, You should have that in your notes, do you not?
Okay, then. So this is the updated book. Then we have to get some more than from you. You giving us more slides, isn't it?
Yeah, those slides that I'm showing you, it's just part of the presentation. So not all of the pictures on the slides are going to be in the book.
Okay, then. I can understand you.
Yeah, so like, let me see. Like this picture, I don't think appears in the notes, does it? In your book?
We have that one, but this one we don't have.
Yeah, that one you don't have, because these are I've put them in just to make the presentation better, so I can explain things better. So not all the pictures on the presentation are going to be in the notes. But the picture you've got in the front of you, the diagram, the circuit diagram, yeah, you should have that.
Yeah, we have.
Hello,
This one we have, yeah.
Yeah, right. So, and you should have that one. Yeah.
Yeah.
We do this one also.
Yes,
You
in
got
page
that one.
number 43.
Okay, so what I was saying, somebody wanted me to explain the spill valve again. So all I was saying is that the blowers are there to pull air into the system. Yeah, so as you get ram air hitting the scoop, that ram air gets filtered, and as these blowers are rotating, they're pushing that ram air into the pipework, into the ducting. Because that air is being compressed as it goes into the duct, it's going to raise temperature. Yeah, and that's how we get this this heating effect from the displacement system. But what's happening as the blowers are running, they are providing far more air than we require. Yeah, so that duct is getting full of air, but that air needs to be the amount of air needs to be reduced, the mass of air, and we do that by using the flow controller. Yeah, the flow controller in the ducting we'll put a little venturi in the duct, and we'll also put a tapping to measure the pressure in the duct as well. So we take two pressures and we use those to operate the flow controller. The mass flow controller, yeah, as air is flowing down the ductwork, yeah, some of that air is going to be directed through a venturi. When we go through a venturi, what happens is the air speeds up, gets quicker, but the pressure drops. So that pressure drop in the venturi here is going to be felt in this area above the diaphragm. At the same time, yeah, I've lost my pointer. Oh, no. There it is. Yeah, at the same time, as air's flowing down the duct, some of that air is going to meet another tapping, and that tapping is going to register pressure underneath the diaphragm. So now we've got venturi pressure on top of the diaphragm and duct pressure underneath the diaphragm. Let's just go back to a colour I can see.
Hello, Jim. I'm not able to see the diagram. I'm just seeing your video.
Can everybody else see?
Yes, sir, I can see. Khagendraji, better. Khagendra,
Can everybody else see the diagram?
Yeah,
better,
I can see you.
better is,
It's lagging, sir.
if someone is not seeing, please go out of the class
Yeah.
and enter it again.
You can rejoin. Rejoin Gonsa.
Okay. Then I'm
Yeah, you
rejoining.
can rejoin. Yeah.
We'll just give him a minute to.
Yes, now I can see.
Now you can see. That's great.
Yeah.
Okay, so you can see we've got pressure going into the venturi, and we've got duct pressure acting below the diaphragm. So we've got difference in pressure above and below. On all this diaphragm is a rubber sheet, basically. As the duct pressure increases, the venturi pressure is going to decrease because the air is going to go through quicker. So we're going to get a reduction in pressure on the top, an increase in pressure on the bottom. So that diaphragm is now going to start to expand. As that diaphragm expands, it's just pulling up on the on a pin. And on the pin, there's a couple of contacts. So as the contacts make, they send an electrical signal to the relay valve, and the relay valve will operate the actuator, and that actuator will open the spill valve. So now the air that's coming through is going to be able to escape. That's going to reduce the amount of air that's flowing through to the metering head. Because you've reduced the amount of air, you're reducing the amount of pressure in there. So the venturi pressure is going to increase because the air is going to slow down a bit, and the duct pressure is going to change as well. So now that diaphragm is going to start to recede again, and as it recedes, that pin with the contacts on, that'll break the contact to the actuator. It'll make the other set of contacts, so now the spill valve will start to close again. So as the spill valve's closing off, obviously the more air is going to get directed through the duct. And again, that's going to be registered at the metering head. Once we're at the right level, we've got the right mass flowing through, that diaphragm is going to go to its neutral position, and maintain that mass of air that's required. If we get too little air, again, the pressure will be felt on the diaphragm. As we reduce that pressure, the spill valve will operate the other way. It'll decrease the amount of air that we're allowing to spill overboard. So this spill valve is constantly modulating. It's opening and closing to regulate the amount of air that's flowing through the duct. Okay with that?
Yeah.
Have I explained that to your satisfaction?
Yes, sir.
Excellent. Right. Anybody else got any questions before we move on? No. Right. So the next.
Jim, sorry to interrupt. I have one question.
Yeah.
In this equipment cooling system,
there
is one line in the note: at greater cabin differential pressures, the flow control valve closes.
In the equipment cooling.
At greater cabin differential pressure, the flow control valve closes.
All right, yeah. Airflows are only
electronic
in the ground are at low cabin differential pressures. Exhaust fans blown through the exhaust air is blown through the flow control valve and exhausted from the aircraft. All that's saying is when the aircraft goes to altitude, if we didn't close that valve, then all your pressurizing air would just escape. So all that's happening is as we gain altitude, as you get a bigger pressure differential, the outflow valve is going to close off, and it's just to preserve your cabin pressurization. That's all. You don't sound convinced.
No, it's okay. It's okay. The greater cavity flow control valve closes.
Yeah. You've got a flow control valve, yeah, and that's controlling the amount of air that's being pushed around in the avionics compartment. Yeah, and that air is then directed so it flows out of the aircraft. So what's happening as we go up to altitude, you're going to get a bigger pressure differential, and because you're using pressurizing air, if we didn't close that or not close it off thoroughly, but close the valve off, yeah, then all you're going to do is pump your cabin pressure air straight through the aeroplane. We need to close that valve to allow us to build pressure up for when we're flying at altitude. Yes, no?
Okay, Jim, I got it.
You sure? Okay.
Okay. Thank you.
That's all that's for. Right. If nobody else has got any questions, we'll move on. Nice steady plod through the rest of this. Where's me? Where we're going? Right. Another type of cooling system that we can employ is what they call the vapor cycle cooling system. The vapor cycle cooling system is basically what you get in a refrigerator. Yeah. Same sort of thing that you get in an air conditioning unit. And all we're doing is we are taking the warm air from the atmosphere, we're running it through the cycle system and cooling that air, that environmental air down. And the way we do it is by absorbing the heat from the surrounding area using a refrigerant. Yeah, it all works on the principle of the change of state of a material. When a material changes state, it gives off a lot of heat, and that is latent heat. So it gives off that heat, but it doesn't change the temperature of the, pardon me, of the substance. So if you've got a block of ice, and ice is a solid at 0 degrees. Yeah, if I apply heat to that ice will start to change state. It will melt. It will turn from a solid into a liquid, but it will still remain at the same temperature. Yeah, so it's absorbed heat, but it's changed state. It's absorbed heat, but the temperatures remain the same. So if I've got a liquid, if I apply heat to that liquid will change state. It will change from liquid into vapor and eventually into a gas. But as it changes, yeah, it's changing the state, but it's not changing its temperature, but it's absorbing all that heat, that latent heat. Yeah, and that's what causes it to change state. And we use that principle in our vapor cycle cooling. And what happens is we take a refrigerant, and the refrigerant is in a liquid state. And as we pass it through the system, yeah, that refrigerant will absorb heat. It will change from a liquid into a vapor, into a gas, absorbs all that heat, and then we can circulate that gas, and we can condense it back down to a liquid, and the system will run all the way through all over again. Yeah. I'll come back to this picture in a minute, because it's the one from the notes. But one that I like to use again, just to help explain the system. We start off with a reservoir. They call it the receiver dryer, but basically it's a reservoir, and in that reservoir is refrigerant, liquid refrigerant. As we pump that refrigerant through the system, yeah, it starts to change state. It starts to move from a liquid into a vapor. We then control the amount of refrigerant that we want to use, and we run that through what they call the evaporator. Yeah, and the evaporator is just essentially it's a posh heat exchanger. So we're going to pump refrigerant through a series of pipes, and as that refrigerant flows through, it's absorbing the heat from the surrounding air, which we're going to blow over the evaporator using when we talk about a blower, it's just a fan. That fan is going to blow air over the evaporator. As that air is blown over the evaporator, the refrigerant in the pipework absorbs all the heat from that air, and that cold air is blown off on the other side. So really, it's just like an air conditioning machine that you get in an office or in a house or wherever. Yeah. As that refrigerant passes through, it's absorbing more and more heat. It's changing state, so it'll come off the other end of the evaporator. It says vapor here, but normally it'll come off as a gas. Yeah, it'll go into a compressor where it's compressed up. The heat is raised. Yeah, and then from the compressor, it's pushed through to a condenser. And all a condenser is, it's an evaporator that works in the opposite direction. So the condenser, yeah, will pump the gas through, and that gas will absorb, as it has cold air passing across it, it will change its state back into a liquid. It'll go through the condenser, it'll change into a liquid, and then the whole cycle can start all over again. Yeah, and that's the principle behind your vapor cycle cooling. So you've got your liquid receiver, which is basically your reservoir, full of refrigerant. The refrigerant, what I should say, is a chemical that is going to boil at low temperatures. Yeah, that's how it manages to absorb its heat. So rather than water with a boiling point of 100 degrees, your refrigerant will have a boiling point of maybe 10 degrees, depending on the type. So it'll readily absorb heat and it'll readily change state. To control the amount of refrigerant that we're allowing into the evaporator, we're going to go through what they call the thermostatic expansion valve. That expansion valve just controls the amount of refrigerant that we allow through the evaporator, and as it flows through the evaporator, it's going to change state. As it comes off the other end of the evaporator, like I said before, it comes off as a gas, yeah, into a compressor. The compressor raises the temperature even more, from the compressor into the condenser, and the condenser got ram air blowing over it. That ram air takes the heat out of the refrigerant. As it takes the heat away, it reverts back to a liquid state. From the liquid, it goes back to the reservoir, the receiver, and the whole cycle starts over again. And that's essentially what your vapor cycle cooling system does. It's just no more, no less than an air conditioning unit, no more, no less than what happens in a refrigerator. Yeah, if you've got your refrigerator empty, yeah, you get your shopping, you put your shopping in the refrigerator, you close the door, the refrigerant's pumped around the back of the refrigerator, and that absorbs all the heat from the produce that you've put in there. As it absorbs the heat from the produce, obviously the produce cools down. The refrigerant goes off, runs down a condenser at the back of the fridge, turns back into a liquid, and it can get pumped around again and again and again. Yeah, so you cool it out to whatever system you want. You cool it back in, your refrigerant. Drop down door, condenser, where we're going to get ram air flowing over. And again, these pictures don't appear in your notes. It's just there to try and help the youngsters understand what's going on. Your receiver dryer, your reservoir essentially. Expansion valve, I'll come on to that. We'll just have a quick look at the expansion valve, how that operates. The evaporator is where the heat transfer takes place from whatever you're doing. In this case, we're trying to cool down a liquid. So we're going to push that liquid in, take that liquid out. Yeah, your refrigerant, anything else I need to mention? Compressor we'll talk about in a minute. Condenser we know about. Servicing point, we'll look at that in a moment, and a filter. Right, the receiver dryer is essentially the reservoir for the system. Yeah, as the refrigerant comes back from the condenser, it's turned into a liquid. It goes into the receiver dryer, and within the receiver dryer, there's a big filter pad. And that filter pad is made up of a normal filtration, and it's also made up of a desiccant. So the last thing we want in this system is moisture, because it would just freeze and block everything up. So any moisture that might have got in is absorbed by the desiccant. The refrigerant flows across it and then back into the system via a stack pipe. And the reason we've got the stack pipe is if there's any contaminants, yeah, they'll all sit at the bottom of the receiver, and they won't get introduced up into the system. Yeah, the liquid then goes off. Yeah, ready to do its job. The top of the receiver, there's normally a sight glass so you can see how much refrigerant's in there. Because it's liquid, you'll be able to see it. Yeah. The expansion valve is there to control the amount of refrigerant that we're going to allow into the evaporator. Yeah, and it works at the outlet of the evaporator. We have a what they call the heat sensing bulb. It's just a little bulb, and it's filled with the same refrigerant as is in the system. As the refrigerant flows out of the evaporator, yeah, the heat from that refrigerant is felt by the heat sensing bulb, and obviously the hotter the gases that comes off the evaporator, that's gonna heat up the refrigerant in the sensing bulb. As that refrigerant in the sensing bulb heats up, yeah, it's going to raise pressure, and that raising pressure is felt on a diaphragm in the top of the expansion valve. That pressure, as it increases, pushes down on a little needle valve, or a pin as it's called on the sketch, pushes down on that pin, and that allows more refrigerant from the system to flow into the evaporator. As more refrigerant goes into the evaporator, as it comes off at the other end, it comes off a bit cooler. Because it's a bit cooler, the heat sensing bulb, the refrigerant that's in there starts to condense. As it starts to condense, the pressure drops. As the pressure drops, the pressure on the diaphragm's relaxed, and the little needle pin starts to close off, reducing the amount of refrigerant that we're allowing into the evaporator. Everybody see that okay? Yes, Jim. Yeah, so that's it. That gets hot, presses down on the diaphragm, which presses down on the wee valve, and that allows more refrigerant to flow to the evaporator. As the temperature coming off the other side of the evaporator cools down a bit, that starts to condense, relieves the pressure on the diaphragm, and the expansion valve will start to close. And again, there's just another schematic of it, which I'll quickly flick through. Yeah, and that's it, opening up. Yeah, so as the heat in here heats up, pressure increases, pushes down on the valve against the spring, that opens and allows more refrigerant to flow through, and that's pretty much it. Yeah, they call it superheat spring. We'll come on to that, but basically it just means that the amount of refrigerant that you're allowing into the evaporator ensures that the refrigerant coming off the evaporator has turned into a gas. The reason we want it to be a gas is because there's a compressor in the system, and if you try to put liquid in a compressor, it'll just wreck it. It'll thrash itself to death. So just going back through this for 2 ticks. Right, so now you can see we've got the liquid receiver, we've got the expansion valve. At the back of the expansion valve is this sensing bulb that we've just talked about. So the liquid refrigerant goes through into the evaporator, it flows through the evaporator, and it absorbs the heat from the surrounding area or wherever it might be. This is saying coolant from canisters. So we're cooling down a coolant. Yeah, as the refrigerant passes through, it's changing from a vapor to a gas. As it comes off the end of the evaporator, it should now be in the gaseous state. That sensing bulb is filled with exactly the same refrigerant. That refrigerant now will start to boil. As it boils, it's going to increase the pressure on the top of the expansion valve. As it increases that pressure, the expansion valve is going to open and allow more refrigerant through to give us better cooling. Yeah. Again, as we cool off, that refrigerant's going to start to condense. The pressure is going to reduce on the expansion valve, and again, that's going to close off the amount of refrigerant we're letting through. So this valve is constantly working, constantly modulating, opening and closing, and it's the sensing bulb, detecting the temperature, the heat that's coming off the outlet of the evaporator that's regulating the amount of refrigerant that's going in. Everybody okay with that? Good, good, good. Definitely silence.
Good.
Yeah, we've just been through that. As I say, it's just a different explanation for the youngsters. Right, so the other components we've got in our vapor cycle cooling system. Yeah, we have the evaporator where that heat exchange takes place. Let's just say we're cooling down the cabin air. Yeah, we're drawing the warm ambient air over the evaporator. That evaporator, the refrigerant, is absorbing the heat from the ambient air, and it's getting blown off as cold air at the other end. As the refrigerant absorbs that heat, it's changing state. It's changing into a gas. Yeah. We want it to come off as a gas on the other side because it's going to go into a compressor, and the compressor is there to pull the refrigerant through the system. It causes a pressure drop in the system and induces the refrigerant to flow. It also, as the refrigerant comes into it, it compresses it. Yeah, it compresses that gas, heats it up, and fires it off to the condenser. From the condenser, yeah, we're going to change the temperature from a high temperature of the refrigerant. We're going to take the heat out of the refrigerant so it'll condense back down into a liquid, and then it can get used again. So that the vapor cycle system is a completely sealed system. Unless you've got a leak or a fault, it should just carry on ad infinitum. Yeah, or until something wears out. Yeah, very, very good. Obviously, there's going to be components within the system and valves within the system. We can't break into the system, so we need to make sure that the thing's lubricated. So there are special refrigeration oils that mix with the refrigerant. Yeah, the different oils for the different types of refrigerant, and that oil gets carried through the system. It'll leave a film on the pipework, so we're not going to get any corrosion in the system, and it's also going to lubricate all the working parts as it moves through. And because the refrigeration oil is mixed with the refrigerant, again, it's going to be continually doing its job as it flows through the system. Service valves we'll have a look at in a minute. We need to make sure that the system is working. We need to be able to check the system. So we're going to put service valves in there so we can check the various components and close the system off for changing things, fill the system up if we need to. So we've got service valves there. And within those valves, we've got Schrader valves. Your Schrader valves are just exactly the same as you get in your bicycle tyres. Yeah, just little one-way valves. Everybody okay with that? Brilliant.
What is the purpose of these Schrader valves?
I'll come on to the Schrader in a minute.
Okay.
Yeah, basically they're like, do you have a bicycle or a motorbike?
Yeah.
Yeah. So when you put air in your tire, yeah, there's a little valve that you press in, isn't there, to allow the air in?
Yes.
Little spring-loaded valve.
Yeah.
Yeah, that is what's known as a Schrader valve.
Okay.
And all it does is it allows, it opens the valve up so you can allow air into the tire. But when you take away your filling pipe, it'll close and it'll seal off to keep the air in the system, keep the air in the tire. And we use Schrader valves for exactly the same purpose on on our system. Yeah, it means we can connect a test hose. We can check the pressure in the system. And then when we take the hose off, the Schrader valve will go into the closed position, so it's not going to leak.
Okay.
Yep.
Yeah.
Right. Compressor then. Yeah, all a compressor is just a little piston driven by a crank, and it's just going to, the crank rotates and the piston goes up and down. Yeah, allows gas from the evaporator. Yeah, it'll come into the piston chamber. It'll get compressed and it'll get forced out to the condenser. Yeah, so as the piston's moving up and down, yeah, it's just going to allow the passage of gas onto the compressor. It also causes a pressure drop in the system, the whole system, which encourages the refrigerant to flow through. Your service valves are there to allow us to break into the system to check the pressures and the temperatures in the system to make sure that everything's running okay. It also allows us to isolate various parts. The compressor service valve, 3-position valve, either fully forward, where am I? Sorry, front-seated, fully forward, compressors isolated from the rest of the system. Yeah, can't get anything through. The mid position, the intermediate position, just allows everything to flow normally. It's quite happy. Your gas flowing from the compressor back into the system. And then the back-seated position again seals everything off. In the intermediate position, yeah, that allows us to put our test gauges on. I'll show you those in just a second. Yeah, so if we've got the back-seated position, the compressor's running, yeah, everything's fine. Refrigerant's being pumped out through the system, but the little service port where we're going to attach our pressure gauges is sealed off. If I want to check the pressures, yeah, I'll put my gauge onto the service thing, and I'll wind the service valve forward a little bit. Then that allows pressure up to my gauge point. Yeah. If I want to change the compressor, if I need to change the compressor, what I can do is wind the valve fully back so that the system is sealed off. Yeah. Sealed off from the compressor, so I can change it if I need to. Just the service valves. Don't worry about the ins and outs of them. Just know that they're there to allow us to get into the system and to check the smooth, correct running. Again, another diagram that's not in the not in the notes, I don't think. Again, just showing us the way the system is going to work. Yeah, we're going to take the warm air from the cabin, the environment, and we're going to pull that across the evaporator using a fan. The fan, for some reason, is called a blower. Yeah, it's going to suck air, warm air, run it across the evaporator, and as the evaporator absorbs the heat from that air, that cold air is going to get pushed on into the cabin. Yeah, your liquid, yeah, from the receiver down through the expansion valve controlling the amount of refrigerant that we allow through the evaporator. That's that little heat sensing bulb that we talked about, full of refrigerant, and that's just going to act on a diaphragm, open and close the valve to allow more or less refrigerant through. Refrigerant flows through the evaporator, absorbs the heat from the warm cabin air, and as it absorbs that heat, it changes from, starts off as a liquid, changes to a vapor, and eventually comes off the evaporator as a gas. It's then drawn down to the compressor, and the compressor's chunking up and down, a little piston, pulling the gas through, compressing it, and pushing it on into the condenser. The air ram air blown across the condenser is going to take away the heat from the refrigerant. As it absorbs that heat from the refrigerant is going to condense back down into a liquid, that liquid back down to the receiver dryer, through the filter, through the desiccant, and then back onto the system. So that the whole thing's running constantly. It's a sealed system, and unless it goes wrong, we don't really need to worry about it too much. Yeah. And as I say, they are good, they are effective, they are efficient. The manifold gauge set is the equipment we need to check the system, to be able to fill the system. And all it is a pair of gauges, one reading low pressure, one reading high pressure. And because the reading pressures, we can convert that pressure to temperature for the particular refrigerant that we're using. And that conversion is done on a scale on the gauge. Yeah, your pressure reading on the outside. So what we do, we've got a set of hoses, one for the high pressure side, red, one for the low pressure side, blue. We connect the hose to the gauge, blue side, red side, and we connect that to the system. Open the valve a little bit, that allows pressure into the gauge, and we can read what the pressures are in the system. And so long as we know what pressure that's operating at, we know what temperature it's operating at, and we can tell whether it's working satisfactorily or not. The yellow hose is for emptying and filling the system should we need to. And again, we'll chat about that in just a moment. On the gauges, we've got a sight glass, so you can see the refrigerant moving in the system, especially when you're filling it. Yeah, you want to make sure that you've got liquid going in, so we'll put a sight gauge on the manifold set so we can see that refrigerant moving. And that's sort of the schematic of it. Yeah. Your low pressure side, your blue hose screwed onto that, little valve, yeah, that will open and close the yellow side. Same with the red side, yeah, we'll put a red hose on there, and again we've got a little valve that will open and close the internal port. Your gauges, yeah, measuring your pressure, and from there we can take temperature. When it talks about the hook, yeah, the hook is this thing here, and the whole purpose of that is just so you can hang the gauges up out of the way, so you're not having to hold them all the time. They're just a support. The yellow port that we mentioned in the center of the gauge for filling and emptying. Yes, so if I want to fill the system up, if I want to empty the system up, I can connect the yellow hose to the system, and I can open one of the valves, and that's going to allow liquid to either be withdrawn from the system or pushed into the system, whichever we're doing, filling or emptying. Again, we don't need to go into the internal workings of the gauges, but I've got to go through it because it's there in the notes. Very important, yeah, is the properties of the refrigerant. Yeah, the refrigerant is going to be non-flammable, and it's going to be non-explosive. It should be non-toxic. However, not all of them are. So if you're using this stuff, just make sure that you wear the correct PPE with it. Any of you guys work with refrigerants? No?
Yes.
Yes, we are using.
Yes, sir, we are using in the JT team.
you're all using it on your aircraft.
Jetstream, yeah, we have a Jetstream 4100.
Excellent. Yeah, so you know what I'm talking about then. So again, you can relate to what we're talking about. Yeah, refrigerant, non-flammable, non-explosive. It says non-toxic, but I wouldn't be breathing this stuff in. You've got to use the correct lubricating oil with the refrigerant. There are different oils for different types of refrigerant, and that lubricating oil will mix correctly with the refrigerant. It says miscible. The oil will be carried by the refrigerant through the system. And obviously, your refrigerant should be non-corrosive, but your lubricating oil is going to put a protective layer in. Yeah. If you take nothing else away from today, take this away. If you are working with refrigerants, wear the PPE. Make sure you wear suitable eye protection. Yeah, this stuff is exceptionally cold, and if you get it in your eyes, you've had it. You're goosed. Yeah. So it doesn't matter whether what you're doing. If you're working in or around your refrigerant, please wear eye protection. Yeah, it's very cold. If you do get it in your eyes, it says rinse the eyes with cold water, and rinsing with cold water, it's going to cause the refrigerant to evaporate. However, you get to that point, the damage is probably done. It says apply a protective film of antiseptic oil over the eyeball. How many of us walk around with antiseptic oil in our pockets? I certainly don't.
No lie.
Nobody?
No, sir.
No, but nobody's going to
Nobody.
walk around with antiseptic oil. If they get it in their eyes, get cold water put on their eyes, and as it says there, get to a doctor. Yeah, doctor as quickly as you possibly can. If you get refrigerant on your skin, it will burn. You won't realize it's there initially because it's that cold. It numbs. Again, we just need to get that refrigerant evaporated. So again, sticking your hand in water or the contacted area in water, get rid of the stuff. It says it's just like frostbite. Never had frostbite, so I don't know, but I can imagine it'd be bloody painful. Another big one at the minute, and I'm pretty sure most countries are the same now. Refrigerants are very harmful to the environment. Yeah, the part of the greenhouse gases. So it's against environmental law to release refrigerant into the atmosphere. Certainly in the UK, and certainly as far as the EASA is concerned, if you get caught releasing refrigerant deliberately, you can face really, really heavy fines, heavy penalties. It's just not worth it. So if you're servicing the system, if you need to get refrigerant out, need to top refrigerant up, do it strictly in accordance with the procedure. Yeah. Says if your refrigerant vapor comes into contact with a naked flame, it produces a poisonous gas. So again, no smoking when you're working around this stuff. And that's your refrigerants, vapor cycle cooling. Yeah. Diagram of a typical cooling system, the 737. Yeah, I just put that on there for showing the guys everything that's involved with it. Yeah. You got your pack valves, you got your air cycle machine. Where we're going to start off from, we'll come from the engine. Yeah, we'll just take the one side. Pack valve switched on. Yeah, air flows through the pack valve via the mixing valve to the mixing chamber. Yeah, rest of that air goes in through the primary heat exchanger. We've seen all this. Through the mixing valve into the air cycle machine, through the compressor side of it, through the secondary heat exchanger, back through to the turbine, where it'll go off then to the water separator. Yeah, the 35-degree switch, it says 2 degrees there, but it's 1.7, I think, 35 degrees. That will be the, if it comes up in the exam, it'll ask you 35 degrees or 1.7 degrees C. Yeah, that's going to keep the air temperature above freezing at the water separator. Yeah, and then that cold air again up to the mixing valve, mixing chamber, and then it can go on into the cabin. Yeah, we've got the various sensors, the anticipator, the limiter, the overheat sensors monitoring the temperature, the cabin controller that's looking to see what the temperature is in the cabin that we've asked for, regulating, talking to the mixing valve opening and closing to regulate the amount of hot and cold air and the direction that it's going. Recirculation fan, we've talked about that, pulling air back from the cabin, yeah, pulling that air back into the mixing manifold before it gets thrown back out into the cabin. Don't forget it's your 60-40 mix, 60% fresh air, 40% recirculated air. Your pack switches, yeah, the on-off switch for turning your packs on and off. The temperature controller, yeah, which is going to set the mixing valve, normal or manual operation. And then the control panel, we can see what's happening in the mixing valve, what the temperature is. We can see by selecting what the temperature is in the duct, what the temperature is in the cabin. And again, if we've got trim air, we've got the ability to select the temperature in different zones of the aeroplane. Ta-da! Anybody got any problems, any questions, any queries with any of that? No?
Sir, I have one question.
Yep.
So can you please repeat this vapor cycle system servicing?
With the gauges?
Okay. Yes, sir. There are 2 gauges, sir. One is blue, one is red, and 3 hoses.
Yeah.
Blue is for low pressure, red is for high pressure.
Yeah.
So can you please give me an idea, sir, how this will work? How can we service through this?
Right. Let's say that's your evaporator.
Okay.
Yeah. That's your compressor.
Okay.
That's your condenser. So condenser, compressor, evaporator, liquid receiver, and
expansion valve.
Expansion valve. Yeah. Bearing in mind, I'm trying to draw with a mouse, and I'm not very good at the best of times. So what's happening? We want to make sure that the evaporator is cooling the air to the required temperature. Yeah. So as the liquid is pushed off into the system, it's going to go through the expansion valve. Yeah, and it's going to go into the evaporator. So what we might want to do is to see what the temperature or the pressure of the liquid going into the evaporator is. Yeah, so we could put our low pressure gauge on. We know what it should be running at. So we'll put the gauge on and see what pressure is going into the evaporator. Obviously, as the gas is coming off the other end, yeah, it's going to get hotter, so the pressure is going to rise. Yeah, so we can put our red gauge onto the service point at the outside of the evaporator, and by comparing the two temperatures or the two pressures, we can work out what temperature change is going on. So different refrigerants have different boiling points, yeah, so that we can tell by what pressure they're operating at as to what temperature they're working to. If you look on the gauge here, the blue gauge, yeah, the black lettering is the pressure that's being registered. The little blue gauges, the chart there, they are there for different refrigerants. So if we've got, let's say on here, we're running a 15 psi. Yeah, that 15 psi will equate to, I don't know, 40 degrees C for refrigerant number 1. Yeah, it might equate to, let's say 50 degrees C for refrigerant number 2. So by looking at the gauge, looking at the pressure, we can see what temperature is running at. So now, you know, we can make sure that the evaporator is doing its job properly, that it's cooling to the right extent. It may be that we want to see what's happening at the compressor, so checking the pressure in and checking the pressure out of the compressor. Yeah, so obviously we can put the gauge in, right, what's happening here. We can have a look at the pressure there. We can have a look at the pressure there, so we can see that the compressor's doing its job. And with those service valves I talked about earlier, they allow us to seal off the compressor from the rest of the system. So if the compressor's not working, by closing off those service valves, we can isolate the compressor from the system. We can change the compressor. Okay with that?
Okay. I'm okay with it.
Yeah, so that's what your gauge sets for. That's what your manifold sets for, and roughly how it's operating.
Okay.
Anybody else got any questions at all? Right. I think what we'll do there, we've had an hour. My back's killing me on this bloody chair. We'll take 10 minutes there. I make it 20:05. Kathmandu, near enough.
Yeah.
Yes, sir.
Okay,
How long?
so 25, 10 minutes, 20:15.
Okay.
There's not a a huge amount left to do, so we'll have 10 minutes there, and then we'll get finished, and I can get some questions sent off to you.
So we will start at 8:15, right?
Sorry?
We'll start at 8:15. 8:15.
Yes.
Number to time.
Yeah.
Okay.
20, 15, 20.
10-minute break.
Okay.
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 See you in a few minutes. Well, 10.
Mr. Jim.
Yeah.
Can you send me some sample question for module 9 essay?
Oh, I don't know if I've got any. I'll have a look.
Kindly, please look.
Yeah, who's that talking to me?
Yadav.
Yadav. Yeah.
Can you revise?
And if you have some spare time, please revise module 9 too.
I can try. As far as essay questions go, I don't think I've got any practice questions, but I'll certainly tell you the ones that I recognise that I've
Yeah,
seen
please.
before.
Okay.
Yeah.
That
I'll
will
probably
be
do
fine
that
for.
towards the end of the week if that's all right, Yadav.
Yeah, no problem. When you have time, please take your time.
Yeah. Okay. I'm just replying to an email, so I'll get back to you in a second.
Okay. Sure. Take your time.
Hello, Jim.
Hello.
Today I missed 30 minutes of your session in the beginning.
Right.
So I hope you don't mind if you could repeat that section 1 for me.
Yeah,
at the
I
end.
can go through that at the end.
Okay, sir.
Yeah. Who's that that's talking to me?
Prakash Chaudhary.
Prakash. Okay.
Okay, thank you, Jim. Thank you very much.
That's all right. Yeah, we'll do that at the end.
Okay, Jim. Okay, thank you, Jim.
Okay, no worries. Okay, is everybody back?
Yes, sir. Go ahead, sir.
Excellent. That's the quickest 10 minutes I've ever had. Okay, so we'll plod on. If nobody's got any questions, I'll crack on. Not a great deal left, so we won't be finishing too late this evening. As it is, one of the guys has asked if I could go over the first part of the notes again. So I'll do that at the end. If anybody wants to hang on and listen in, you're more than welcome. Other than that, once we've finished, I'll get some questions out to you, same as I did yesterday. I'll get them written up and send them off to Yadev. So where we're going with this, we've had a look at the gauges, we've had a look at the manifold set. The next thing we need to look at is small aircraft. Yeah, small aircraft, obviously, we're not going to be able to fit vapor cycle cooling systems in. We're not going to have displacement blowers, far too big and heavy, and it would drain too much of the engine capacity. So what they do with some small aircraft is use little burners, little combustion heaters to heat ram air that's coming in. So we'll duct ram air in and we'll put it through it literally a combustion heater burner. Yeah. It does go through the ins and outs of the combustion heater in the notes. I'll just run you through the salient points. We don't need to worry too much. Pardon me. I'll get too bogged down in all the ins and outs of the heater. But basically, the combustion heater is just a little chamber with a fan in it, and that fan is going to pull ram air across a heating element, and that heating element is burning fuel. Yeah, so the heating element, as it burns the fuel, obviously that's going to burn hot. As the ram air flows across it, that ram air is going to take the heat from the burner and we'll pump that into the cabin. Keep your little pilot nice and toasty. Yeah, so the combustion heater, all we're doing is taking a little tapping from the fuel supply, igniting that fuel, burning that fuel, and as that fuel burns in the heater, run ram air across it. As the ram air flows across, it's going to absorb the heat, so we get nice warm air flowing into the cabin. And that's essentially what our combustion heater is. Yeah. We have a fan. Yeah. And that fan is going to take a small tapping of air, yeah, and blow that up into the center of the chamber. Behind that, there's a fuel supply with an igniter, and as we skirt the fuel, turn the igniter on, that fuel will start to burn, and it burns the air that's being blown in the combustion chamber. Yeah, we've got a big fan that's going to pull the ram air from outside the aeroplane across the heater, so that fan's going to be running. Yeah, fuel supply, small fan for burning, and away we go. All controlled from a control panel in the cabin. Yeah, so we switch the heat on. Big fan runs, ram air. Little fan runs, blows air into the heat chamber, ignited, burny, and the exhaust from the burnt air is vented overboard via an exhaust pipeline. Important thing to take away from this is that the ram air, yeah, that's blowing across the heater is always going to be at a higher pressure than the air being burnt in the combustion heater. And the reason for that is if we get partially burnt air, we're going to get carbon dioxide, or carbon monoxide, I should say. And we don't want that escaping into the cabin and what's the word I'm looking for? Making the pilot feel bad. Yeah, not decapitating, debilitating the pilot. So to stop poisonous, noxious gases escaping, the ram air through the heater is always at higher pressure than the exhaust, if you like. Yeah, so we've turned on the heater, turn on the fuel, ignite the fuel with a sparker. That's going to burn, warm it up, and away we go. Sensors, so when we're at the right temperature, yeah, a little thermostat will stop the fuel flowing. The igniters will carry on working, but the fuel flow will be shut off. So as the temperature drops, the thermostat will pick up on that. It will open the fuel line again. Fuel will start to flow. The igniter will catch it, and the whole combustion process starts again. Alternative controller in case we get a failure in the main system. Yeah, if you get a faulty thermostat, we've got that temperature limiter switch. So if the thermostat fails, the system starts to run too hot, the thermostat will shut the system down. Once it's reached a safe temperature, we can reset the system. Yeah. Should we get a failure, there's a further safety switch down the line. If the temperature carries on rising, it'll get to a certain point. The system will close down, and we can't reset it in the air. We've got to reset it on the ground once investigation's been carried out. If you want cold air only, yeah, we can, again, from the selector, we can just select fan. Ram air fan will run and just blow cold air across the heater. The heater's not working at all. Yeah. Where's it going to go? Yeah, the air through the little blower up to the combustion heater. Yeah, fuel supply. Your ram air's coming in, blown across the combustion heater at a higher pressure than the pressure in the heater. And then that'll get ducted off to wherever it needs to be. If we just want cold air, yeah, we're again cold air to the little louvers that we talked about before. Yeah, so we can just have cold air blowing into the cabin should we need it. Yeah, this is just going to step through, just showing what's happening. Hopefully there. Right. That's your small combustion heater. Because you are burning fuel, that if that fuel doesn't burn thoroughly, we can get carbon monoxide given out. And carbon monoxide is lethal. You can't smell it, you can't taste it, you don't know it's there until you start getting the symptoms of carbon monoxide poisoning. The onset of carbon monoxide poisoning can be very, very rapid because you don't know you're breathing it in. Yeah, you can start to feel a bit woozy, a bit sleepy, nod off, and you carry on breathing the stuff in, and eventually it will kill you. There's numerous stories of people that go out on holiday to holiday homes where the boilers don't work properly, and the boilers are pumping carbon monoxide into the holiday home. Aviation-wise, does anybody remember? I think it was about 2 years ago. There was a footballer. He'd gone from France to UK, and his aeroplane crashed in the sea.
Yeah, I know.
Yeah, do you remember that story? Well, they found one of the bodies, and when they were doing the autopsy on the body, they found that I think it was the passenger, but they found that there was a lot of carbon monoxide in his blood. So that it's not been confirmed, but they suspect strongly that the combustion heater was leaking and had leaked poisonous fumes into the cabin, and that's what caused the pilot to be incapacitated and led to the loss of the aeroplane. So if we need to check that we've not got any carbon monoxide present in the aircraft. So there are lots of different types of detector that we can fit.
Hello.
Hello. I didn't understand any of that. Yeah, carbon monoxide. Yeah, the aircraft, if it's got combustion heater in it, it's going to have some sort of detector. The simple common detectors are just little plastic cards with a spot in the middle of it. If there's carbon monoxide present, that spot will start to change colour. Yeah, it will start to go grey, and depending on the concentration, it'll go black. Yeah, so if you see the detector changing colour, we know we've got contamination present. We can do something about it. These things are, as you see on the screen, they are replaced every so often. It says 12 months here. We can get electronic carbon detectors. They're a bit like smoke alarms that you get in your house. Yeah, but they will detect carbon monoxide. They come in different sizes, so you can get them fit for use on your small aircraft. The equipment that they talk about in the notes is a little hand pump. And the little hand pump, it's just a set of bellows, and in the end of the bellows we put a glass tube. That glass tube has got crystals in it. Let's just go back one stage. Yeah, glass tube, crystals in it, and those crystals start off life as white. Pardon me. To get the thing to work, what we do is snap the ends off the glass tube. And that leaves the crystals open to atmosphere. We squeeze the pump, little hand pump, and that's going to draw air in across the crystals. If there's carbon monoxide present, those crystals will turn to a green-brown colour. Yeah, sort of. I'm not sure whether I'm allowed to say shitty colour, but they are. Yeah, it's a greeny browny colour, and that will tell you that you've got carbon monoxide present. Right, at this stage in your notes, where it talks about those tubes, the section entitled carbon monoxide detection. Yeah. And as we talk about the test, it says there is usually a times scale for small concentrations and a times scale for large concentrations. What figure is it showing in your notes there?
$22 for small concentrations and 10 for large concentrations.
Right. That amendment, the change to the notes of it hasn't got through to you guys. So what I'd like you to do is change that 22, just change that to 2. Times 2 for large concentrations. And where it says times 10, change large to small concentrations.
Kindly confirm times 10 is for the small aircraft.
for small concentrations of carbon monoxide, yeah.
Yeah, a small concentration.
Yeah, because what happens is, I'll talk you through it. But with these crystals, yeah, we've got this glass tube, and the crystals are in the glass tube, and we snap the end off the tube, and we pump the hand pump, and that pulls air across the crystals. Initially, if we're checking, we give it 2 pumps, and if there's a lot of carbon monoxide, it's going to stain those crystals very quickly. Yeah, so it should be times 2 pumps. If nothing else shows, yeah, we pump the bellows another 8 times, so we pump it a total of 10 times. So if there's small concentration of CO2, by giving it 10 pumps, again, if there's anything there, it'll show up by staining the crystals. I've got to be honest, I don't think that comes up the amount of pumps you do, but the green-brown staining, I've seen a question on that before now. Yeah, so just watch that one.
So
Finally, one highlighted.
Jim, I have some question.
Yeah.
When we go through this book, we are being provided by the institute. If carbon monoxide is present, the spot will turn gray or black within 15 minutes. Even side darkening index indicates a dangerous carbon monoxide concentration. It has been written gray or black, but your PowerPoint presentation shows green/brown. So if such type of questions has been asked by the examiner, which
no, it's 2 different things, isn't it?
Yeah.
If you look at that card, yeah, it says carbon monoxide detector consists of a small plastic card incorporating a pink chemical spot. Yeah, that package is placed on the instrument panel. If CO is present, the spot will turn grey or black. Yeah.
Okay.
Yeah. So that's for that card. The next tester is the little pump that I was just talking about, and that little pump is the one with the glass tube in it. Yeah. So if you go further down that page, ends of the glass tube are broken off, indicating end inserted into the air intake opening of the pump. Pump fully compressed, and when released will expand and draw specified quantity of air through the sampling tube. Yeah. 2 samples drawn through the tube. The presence of carbon monoxide is indicated by green-brown staining of the white crystals. So it's 2 separate detectors.
Okay, thank you.
Okay with that?
Yes.
Anybody else?
hello, Jim.
Hello.
There is usually an times 22 scale for small carbon monoxide concentration and 10 scale for large concentration. This means 22 for small and 10 for large, no?
It does, but the text isn't quite right. What happens is you put the tube in the hand pump, and you give the hand pump 2 squeezes. Yeah, and that 2 squeezes will pull air in over the crystals. If there's carbon monoxide present, it will stain it pretty much straight away. If there's a large concentration, if nothing happens, if it doesn't change colour, then you give it another 8 pumps, so a total of 10 pumps. And again, if there's a small concentration, 10 pumps of air will register. So that's why I was saying we need to just change that.
You mean this 22 times is not a 22, it's only 2 times?
as I say, I've not seen a question on the how many times you pump it, but certainly when it talks about the pump, what colour do the white crystals change if carbon monoxide's present? The white crystals will change to a browny greeny colour. Yeah, the grey colour, the grey colour is for the card type.
You mean that in the place of 22, we should read only 2? We should eliminate
2,
1.
yeah. And
that
so that sentence should read, there is usually a ×2 scale for large CO concentrations and a ×10 scale for small concentrations.
Here is written not there is usually, and 22 is scale for small.
Change
and
22
10 scale
to
for
2.
large concentration. Okay, only 2 for small, no?
2 for large concentrations and 10 for small concentrations. It's just been typed up wrong.
Okay.
I do understand the bigger is.
Yeah.
If you've got a lot of carbon monoxide in the air, yeah, just 2 pumps and you're going to see it. You're going to see the crystals change colour straight away. If you haven't got a lot of carbon monoxide in the air, you need to pull more air across the crystals. Yeah. So
Okay,
the ×10 pumps is going to be for small concentrations. ×2 pumps will be for large concentrations.
Now my confusion is eliminated.
Negative. We have to realize as a negative, yeah.
All right. This is the thing we're talking about, yeah? And what we do is we squeeze that pump, it's going to pull air. So let's have some blue air. It's going to pull air in over the crystals. Yeah, that tube is full of white crystals. If I give 2 squeezes, yeah, the air that's pulled through, if there's a lot of carbon monoxide in the air, it's going to stain those crystals pretty much straight away. If those crystals remain white, yeah, if I give it another further 8 pumps, so a total of 10 pumps, if I've got a small concentration of CO, yeah, the extra pumps, the extra 10 pumps, if there's carbon monoxide there, again, the more air that I pull across, then it's going to stain those crystals. So for small concentrations, I need to do 10 pumps. For large concentrations, I only need to do 2 pumps.
Got it.
Okay.
Yes, sir.
Everybody else all right with that?
Yeah.
Sound. Right, so those are our carbon monoxide detectors. Thing to take away from that, like I say, remember the crystals, remember that carbon monoxide is extremely dangerous and hazardous to your health. The other type of heater that we get that is mentioned in the notes there are exhaust shroud heaters. The exhaust shroud heater is all it is a tube that's wrapped around the engine exhaust pipe, and it takes the heat from the engine exhaust pardon me, and ducts that into the cabin. Unfortunately, on this, I haven't got a picture of it, but the mufflers, the heater shrouds, they're just bits of foil that wrap around the exhaust with a takeoff pipe on them, and the heat from the exhaust heats up the air in the muffler and directs it into the cabin. Yeah. Again, these things are used quite often on small aircraft. Yeah. But again, we need to be very careful that there's no carbon monoxide introduced into the aircraft. So the heaters and the shrouds are inspected regularly. Yeah. The mufflers pressure tested to 2 psi, and the heaters inspected and tested at a period not exceeding 500 hours or 2 years. And that's just to make sure that there's over a period of time they've not deteriorated, they're not going to leak, they're not going to create any problem for us. Anything else I need to say there? Yeah. Any leakage from piston engine exhaust heaters, combustion heaters may cause dangerous carbon monoxide contamination. Yeah, found in various amounts. Yeah, absolutely horrible. Exhaust shroud heaters must be maintained in accordance with the maintenance schedule for the aircraft. Visual inspection of the system, looking for any signs of leakage. Cabin heater, the cabin heat exchanger must be pressurized at the interval stated. Yeah, removed from the aircraft, everything's blanked off. We pressurize it to 2 psi and dip it in water, and we look for leaks by looking for any bubbles in the water. Combustion heaters, exhaust systems maintained in accordance with the maintenance schedule. 747 GR11 requires that intervals not exceeding 500 operating hours or 2 years. The heaters, the exhaust systems got to be dismantled, inspected, and then reassembled and tested. Your combustion heaters, have got to be pressure tested to between 3 and 5 psi to make sure that they maintain their safety margin. Yeah, so carbon monoxide, very, very dangerous, colourless, odourless, tasteless. Exhaust heaters, exhaust shrouds, inspected regularly. The heaters, combustion heaters, maintained every 2 years or 500 hours, whichever's the sooner. The regulations for checking them is in CAP 747, which is all the safety stuff. And your shroud heaters have got to be pressure tested between 3 and 5 psi to make sure that they're not leaking. And that, guys, brings us to the end of our air conditioning side of things. Has anybody got any questions at all on anything that I've covered today?
Yeah, I have.
Okay, shoot.
Then this turbo compressor or bootstrap air cycle are the same we studied in air cycle machine.
Yeah.
And when there is turbine drive the compressor.
Yeah.
And what about the waste gate? It's written. What is the waste gate?
What page are you on there?
No, I have a question. That's why I'm asking this. It's not written. I don't know where in the notes I have to search.
Well, if it doesn't mention wastegates in our notes, then it's not going to come up in the exam.
Okay. And in the multi-engine aircraft, how the air cycle machine are means how the distribution is done?
Say that again. Sorry.
In the multi-engine aircraft,
Yeah.
how the distribution are in cabin means from what engine, how to the distribution is done?
Well, it goes from the engine to the cooling pack, from the cooling pack to the mixing chamber, from the mixing chamber to the cabin.
So if there are 4 engines, then how it is done, that I'm asking.
Well, again, it depends how many cooling packs you've got fitted. Normally, there'd be a cooling pack associated with an engine, or it may be that you've got 2 engines feeding into 1 cooling pack. Just give me a second. Let's go back to me.
Okay.
Excuse me, sir. There is only one mixing chamber in particular aircraft.
So just give me a second. I can find a decent diagram. All right, if we look at this diagram, this is a 737, yeah, multi-engined aircraft, 2-engined aircraft. The 737, yeah, has got two cooling packs, a left-hand one and a right-hand one. Forget about the bottom bit. Yeah, we haven't covered the bottom bit yet, but we're going to take air from the engine. We're going to cool that air down a bit. Yeah, and then we're going to run it up to the cooling pack. Can you all see that okay? Hello?
Yeah.
Okay, right. So the air's coming out from the engine. We'll treat that. We'll talk about that another day, what we're going to do. But we're going to pump that air up to the cooling pack, the pack valve. We open the pack valve, and that's going to allow that engine air to flow through. Yeah. Some of that air is going to carry straight on to the mixing manifold, that hot air. It'll go via the water extractor, but that's by the by. The rest of it is going to go down through the primary heat exchanger. From the primary heat exchanger, it's going to go into the compressor of the air cycle machine. From the compressor through the secondary heat exchanger and back up to the turbine of the air cycle machine. From the turbine, it's going to go into the water extractor, and then that air is going to go to the mixing manifold, yeah, where everything's mixed. You can see that the right-hand side is exactly the same. Yeah, so we turn on the pack valve. That right-hand side is going to do its magic, and the air that comes out is all going to go into the mixing chamber, and then from the mixing chamber, it's going to get sent off to the distribution ducting in the cabin. Yeah. So you know, if you're talking about a 4-engined aircraft, you might well have four cooling packs, but they're all feeding into the common distribution system.
You mean to say that it all works in a parallel manner?
Yes, yeah, but each engine is isolated from each other. If you didn't have the isolation switches, all you'd be doing is pumping air from one side to the other. Yeah, so you've got the isolation switches there to make sure that the air from the left-hand engine goes into the left-hand pack, right-hand engine goes into the right-hand pack. If you have an engine failure or a pack failure on the right-hand side, then we can open the isolation valve and use the left-hand side to feed in as well.
Okay, got it.
Okay.
Okay.
Yeah.
Anybody else got anything? No, all deadly quiet. With everybody's happy, we're with a little bit early, but I'm going to go through from the start again for whoever it was that asked me, Prakash.
Yes, sir. Yes, sir. It's
yeah. So if anybody wants to stay with us and go over that again, you're more than welcome. I'm
Excuse me,
just going to have 10 minutes. Yeah.
I have some questions. Can I ask you? In the text, in the textbook, I found two different things regarding conditioned air distribution. Somewhere it has been written that it is distributed to the cabin through the series of riser, and somewhere it has been written that conditioned air is distributed to PAX cabin through underfloor and a head rack ducting. So in this case, we get confused, because ultimately we have to face the exam and we have to mark the correct one. So
yeah, don't get confused. The riser, all the riser is a duct. Yeah, and that riser, it's just ducting going up from the pack to the hat rack stands. Again, just let me go back and just see if I can find the decent picture for you guys. So I'm just trying to get the right picture up here. It's not playing for me. No. Just bear with me a minute. Right, when it talks about the risers, we've got the cooling packs under the belly of the aircraft. And from the mixing chamber, we've got to get that air up to the distribution ducting. So when it's talking about the risers, it's just meaning the pipework that takes the conditioned air up to the distribution ducting in the cabin compartment. Yeah, so yeah, see your mixer. So you've got to get the air to up to the roof of the cabin. So the risers are just those sections of pipe work that are running up from the packs up to the distribution pipe work in the roof of the cabin.
Okay. Okay.
You okay with that?
Yes.
You sure? Pinky promise?
Yes.
Okay. Anybody else got any questions at all?
Jim, did we cover this chapter 5, air cycle system? Turbo compressor or bootstrap air cycle machines?
Yes. Yeah, that air cycle system is exactly what we've covered. It's just repeated information. Yeah, so we know about the heat exchangers. Yeah, how we're getting rid of that heat. Expansion, contraction, compression. We know what charge air is. We know what ram air is. The bootstrap system we mentioned right at the very start. Yeah, so all of that is just repeat information, which is why I didn't bother going over it again.
Yeah, it seems like. Thank you, Jim.
That's quite all right. Anybody else?
Yes, it's James. I have seen somewhere one question. I have seen somewhere one question that what should we do before recharging the vapor cycle? Is it it means to say that we have to discharge the pressure first, or while filling pressure? I can't get this question.
I can't understand what you mean.
What must be done before recharging the BCCP? It's I think yeah, vapor cycle.
Yeah, if you're going to recharge that system,
yeah,
you've got to bring it down to a vacuum before you put liquid in. And the reason you bring it down to a vacuum, using a special pump, a vacuum pump, you bring it into a negative pressure, and that just makes sure that any moisture, any air that's been introduced has been pulled out. So by taking all the air out, you're taking all the moisture out, so you're not introducing moisture into the system. So before you charge it, you've got to make sure that it's down to a negative pressure.
But
okay with that?
Yeah, thank you.
Yeah. What I would say on that, if you're filling a system, you're going to follow the maintenance manual procedure anyway.
Okay, Mr. Campbell, I'm really happy to you. You got us a lot of information.
You know what? Sorry, you have to shout at me. I'm deaf.
Oh, sorry. I'm Surendra.
Surendra, yes.
Yeah. You got us a lot of information regarding this matter. Air conditioning, yesterday, structure, so and so. We got a lot of things from you. Hope we will get more. So, my friends are asking sometimes stupid questions. Isn't this is not reliable?
No, everything's fine. I'll send some more questions like I did yesterday. I'll send some more questions to you.
Mm-hmm.
Okay.
Okay then.
Yeah.
We have to. I'm coming on the point. We are the learning with you. You are giving us a lot of information. So as much as we are giving information from you, and then we can take clear our ESI exam, then we all are becoming certifying what called that technician or engineer. That's our government decided.
Yeah. So once you've passed all your modules and you've got your experience,
Exactly.
then yes, you can get your EASA certifying license.
Mm-hmm. But my colleagues are anyway. I don't have any problem with my colleagues.
Mm-hmm.
But I have a problem. Problem that the once electrical system is coming there, I'll be very open. Maybe tomorrow. What we have class tomorrow?
Yes, we're going to do ice protection tomorrow.
Maybe there is included some electrical system.
No, we're just doing the mechanical systems at the moment.
Okay, then it's okay.
The electrical stuff comes in module 13, which I can't remember when you start module 13.
Okay. Thanks, Jim. I would like to thank to you. You are doing very well.
Oh, thank you. That's very kind.
Because I've been near country. I've been a lot of country. I've been among the old. I've been around 70 countries.
All right.
I was in the army aviation in the beginning. In the beginning, same like you. You are from the Air Force.
Yeah.
We don't have Air Force. We have army aviation. I was from there.
Right. Okay.
After that, I went to the US.
Oh.
For 14 years.
All right. Very experienced then.
And then I was working in the cruise ship as an engineer.
Were you a singer, were you?
Norwegian Cruise Line. Do you hear that?
I heard cruise, yeah.
Cruise, only cruise. Norwegian Cruise Line.
Right.
And then I worked for them 14 years as an electrical engineer.
Ah, right. So you weren't one of the dancing troupe?
That's a 7-star cruise, and then everything happened there. But I was an electrical engineer.
Right. So all the electrical side of it comes in a couple of weeks when we do module 13.
All environmental things, and then everything. I had a headache with the. I think around 1200 motors. That's a big motors. I have to take. And then systems, environmental system, incinerator system, everything I have to take over that. I got it. Anyway, I'm from the old poorest country, but I did something else.
Congratulations! Oh, it's well done. It's great.
Mr. Campbell, that's why I'm calling you Mr. Campbell. No one knows that how to pronounce English.
Right. Just call me Jim Surrender.
Excuse
No,
me.
I'll call you Mr. Campbell.
Okay then, if that's.
Excuse me, Mr. Campbell. Can you have 5 minutes break?
Yeah. I was going to say 10 actually.
Okay.
Okay, then 10 minutes.
Okay, Campbell, I'll interrupt you.
10 minutes is okay.
Yeah,
10 minutes,
10
okay.
minutes will be okay. Nice good to
hear
have a
you.
break now.
Topic, if it is about topic, I can hear you. If it's personal, I can't. But before that, I called you personal. That's different matter.
Okay, no worries.
Okay. Okay, Mr. Campbell. I'll keep in touch with you.
Okay, thank you. Right, we'll have 10 minutes there. I'm going to go over the front part of the book again.
You, if it is
Okay, 10 minutes break is okay.
Yeah, 10 minutes, and then if anybody wants to join us, you're more than welcome.
Okay.
If you don't, then I've finished today's subject.
Okay, thank you.
Mr.
Okay,
Campbell,
so
British Virgin Islands.
Jim, I'm here. I told you that I have missed your 30 minutes session from the beginning. So I would wonder if you could repeat that for me.
That's why I'm going to do it now. We're going to have a 10-minute break, and then I'm going to do that first session again. As far as everybody else is concerned, I've finished for today. So if you want to listen again, you can. If you don't, then we've finished for today, and I'll get some questions sent out to Yadev.
Okay, we'll catch you after 10 minutes, Jim.
Okay. Is everybody okay with that? Everybody understand?
Yeah.
Okay, James.
Okay. 10 minutes then.
Okay.
Okay.
Hi, Jim. Hi, Jim. You are there? Hi, Mr. Campbell. You are still there?
Yeah. Who's that?
Okay. I would like to speak with you for better things.
Yeah.
So,
Who's talking to me?
Surendra.
Surendra. Right.
So, we are just talking for not for the topic, this topic among the ESA. We are talking formally.
Family.
Yeah, each other.
Uh-huh.
So, from Scotland, yeah?
Sorry?
You are from Scotland?
Yes.
Yeah. I've been there. Unfortunately, I missed that opportunity to get to the country.
Mm.
I've been in London, I've been in Ireland, I've been in Norway, surrounding over, but I didn't have time to. That time I was in Nepal.
Right.
Okay. So it was in the Air Force.
I was in the Air Force. Yeah.
And same here. I was in the not we don't have Air Force. Nepal is the very small country and very poor country. You know that.
Yeah.
Very poor country. We are the very poor country. So,
James, should we begin begin revising chapter 1?
If I've got everybody back, yeah. If you want to go over that.
Yes, go ahead, sir.
don't query about the questions, okay? Regarding our topic, we are talking.
I don't know who's talking to me, but you're very, very broken.
Yeah, you are right, Mr. Jim. Some student are in lobby. Please accept.
Yeah, I've done that. Nobody in the lobby at the minute.
All we respecting you. That's the way. Loving,
Mr. Jim.
we loving you because you are giving us something.
Right.
I think.
I don't know who's talking to me, but you're coming across very, very broken. It's very, very bitty.
Broken.
I think we quit today.
Yeah, that will be good idea, Mr. Jim.
So I have to I have missed 30 minutes of the session. So Mr. Jim, I request you please.
Mr.
Hang
Campbell.
on. I'm getting snowed under here. Can I have one person at a time talk to me?
Okay, he may talk with you personally. At the moment, can you quit for today? It will be better.
Yes. All I'm doing, I'm going over the first bit of the notes for Prakash who missed it.
Yes,
so if you're happy and you don't want to listen in, that's it, and I'll send some questions to Yadav later on.
We are happy more than
If you want to listen in, you're more than welcome. If you want to call it a day, you're more than welcome. We'll be doing ice protection tomorrow, so I'll see you in the morning.
Okay. That will be better, I think. Prakashji.
Yes.
Can you make it happen tomorrow? Please.
No, I have to continue today. I have to finish this chapter because I don't want to,
no, it cannot be, because if you are late, why can you ask to the teacher? You are late. You cannot ask for time.
Okay, Jim, should we start? Jim?
Right. Yeah.
Okay, I think we should start now.
Okay, everybody else happy? Anybody that wants to join in, you're more than welcome. I'm not going to dwell too long. I'm just going to quickly skip over the first bit. Yeah, we talked about environmental systems. And we said that we need environmental systems for comfort and to be able to survive at the high altitudes the aircraft are flying. There are different types of system for different types of aeroplane. The first system that we looked at was for the jet engine type aircraft. Yeah. The compressor bleed air system, your jet engine type, is known as a bootstrap system. And all bootstrapping means is bringing something to the required state through its own action. So what we're doing with a jet engine system, we're taking hot air from the engine, we're making that air work, and we're bringing it down to a usable temperature through its own work. Yeah, that is what bootstrapping is. That conditioning of the air is done through the air conditioning packs, and the pack is just collectively all the components located together for bringing the air into the desired state. There are different components that we'll have a look at, and they're all controlled from the cabin, from a control panel in the cabin. Sorry about that. Yeah, there's an on-off switch. Yeah, the pilot can turn the air conditioning system on. You can turn the bleed air system on, and then we've got the relative gauges, the instrumentation, so you can see what's happening. Warning lamps, the temperature from in the ducts and in the cabin. What's happening with the mixing valve, making sure we've got the correct temperature. And warning lights if anything goes wrong. The way it works is that we will take air from the engines, yeah, and we will put that hot air from the engines into the cooling pack. The cooling pack is opened again from the flight deck an on-off switch, and the pack valve is selected open or closed. Between the engines, we've got the isolation valve, and that just means that you can't cross-feed one engine to another unnecessarily. Yeah, so if we had a failure in one side, we can open the isolation valve, and that will feed the opposite side. So what I'll do, I'll just look at the left pack. Yeah, the pretty much duplicated. Engine 1 running away there, and it's producing bleed air. Open the pack valve, and that allows that engine bleed air into the cooling pack. Some of that hot air is allowed to bypass the cooling pack, and that goes straight off to a mixing chamber. The rest of that engine air is treated and it's cooled down, and that's brought to a really cold temperature. And again, once we've done that, we put that into the mixing chamber. From the mixing chamber, that air is then directed to the distribution manifold, your hat rack, if you like, the ducting in the top of the passenger cabin, and then it goes off to the cabin to treat the passengers. With this type of system, we're using this air for pressurization as well. So we're conditioning the air, and then we're going to use it for pressurization, which we'll talk about another day. It also allows us to tap off air for the flight deck, for the crew. So we're pumping air into the main cabin, and we're pumping air onto the flight deck, nicely warm through, so it's all comfy and cozy for the crew. Yeah, that main distribution manifold, when we were talking about the risers earlier, all we're doing is taking the air and pushing it up the way so it gets to the main distribution pipework in the cabin, and from there it's just sprayed out again to keep us nice and warm. We need ram air as a cooling medium for our conditioned air. Yeah, we're going to use ram air as a coolant, and we need to be able to control the amount of ram air that we're allowing to flow over the heat exchangers, and we do that via little deflector doors in the ram air scoops. So as the aircraft's flying along, yeah, by varying the position of the door, we're regulating how much cold air, how much ram air we're allowing to flow into the heat exchangers.
Okay.
So to put all that into a bit of context, yeah, the pack valve opens the pack, so the pilot will make a selection on off. Yeah, the pack valve will open, and it will allow air from the engines into the pack. Some of that hot air will go straight over to the mixing chamber via the mixing valve. The mixing valve is a sort of two-way valve. Can you see my picture on the screen?
Yes, I can see you. I can listen you very clearly, and I am understanding the things.
Can you see the presentation as well?
Yes.
Lovely. Right. Well, if you look at me, the mixing valve is a bit like this. Yeah. So as I open one valve, the other one starts to close. So if I've got cold air coming this way, hot air going this way, as I close off the cold air, the hot air is going to start to open. So that's how your mixing valve operates. Yeah. So depending on the temperature we want, the position of the mixing valve will allow some hot air in the mixing chamber. The rest of that engine air is going to go into the air cycle machine. First thing it's going to do is flow through the primary heat exchanger, where ram air that we've allowed through that ducting, ram air is going to flow across the primary heat exchanger, and it's going to take some of that temperature out of the engine air. Yeah. from the primary heat exchanger, again via the other flap on the mixing valve, it's going to go into the air cycle machine. And the air cycle machine consists of a compressor and a turbine joined together on a common shaft. Yeah. So as the air flows through the compressor, we'll pass the compressor. It'll then go through the secondary heat exchanger, and the ram air again that we've allowed through flowing across the secondary heat exchanger is going to take some more of the temperature away from that air. Once it comes out of the secondary heat exchanger, it goes up to the turbine. When it goes into the turbine, the air is expanded, it drops pressure, and at the same time it drops temperature. Because the turbine and the compressor are on a common shaft and the turbine blades are a bit bigger, as the air strikes the turbine, it starts turning the turbine, and the turbine drives the compressor. Yeah. So any residual heat in that air is now converted from heat energy into work energy. So the turbine driving the compressor takes away the remaining heat from the air. From there, the treated air comes out of the air cycle machine into the water separator. Right. As the air comes into the compressor, a certain amount of it via again a little control valve, a certain amount of hot air is ducted past the air cycle machine, and that air is controlled at around about 35 degrees Fahrenheit. And the reason for that is the air coming off the turbine is going to be very, very cold, and we don't want any moisture in there to freeze. So the air that's coming off the turbine, we maintain it at around about 35 degrees Fahrenheit, so that it's above freezing when it goes into the water separator. Via the water separator, we extract all the moisture from it. Then that cold air goes up to the mixing chamber, where it meets up with the hot air that bypassed the cooling pack. It all swirls together, mixed together, and then it goes off to the distribution manifold, where it's pumped off into the cabin. The ram air inlet, we said that we needed to control the amount of ram air that we're allowing to flow across the heat exchangers, and we do that via the deflector door. That door just modulates, it opens and closes, and just regulates the amount of air.
ढिलो आएर अब फेरि त्यो रिपिट गर्न लाउँछ भने कहाँ हुन्छ? हामी यो भन्दा पहिले क्लास गरेको बेला छ नि, त्यो टिचरले पुरै अब जस्तो आज क्लास सिद्धियो नि अगाडि, अनि 1-1 घण्टासम्म रिभ्यू गर्थ्यो क्या। क्वेशन्सहरु मात्रै उले सोध्ने, हामीले सोध्ने, उले सोध्ने, हामीले सोध्ने, अनि यो बुकको सबै उले गराउँथ्यो क्या। अब सब यहाँ आफ्नै आफ्नै तालको छन्, अब के भन्ने? उलाई टिचरलाई रिस उठिसकेको थियो क्या।
I would like to say
हैन सकिरहेछ, मेरो सकिरहेछ है, म एकैछिन सकिसक्यो नि, अब यही त हो है, त्यो च्याप्टर 1 त थियो।
He is not coming on time, then you don't have to repeat.
Jim, do you have any problem? Then I can quit.
No, but I want to get through it. I'll finish at 4.
Okay, Jim. Thank you very much, Jim. We will finish it.
I'm quite happy to go through this first bit if you want me to.
No, my friends are telling that you are, you are getting angry.
They don't have to listen in. They can go.
Excuse me, please.
Okay, sir. Okay, Jim. We are just we are almost finished this.
Jim, you can summarize this so that everyone will be refreshed, and the new guy also can learn it. It's not problem, but you can finish it in some minutes so that we can solve other problems also.
Yeah, what other problems have I got?
Okay, Jim.
So the questions who other guys want to ask also.
Okay, so there's other people. There's people want to ask me questions, is there?
Yeah. Okay. First, you finished his finish this chapter because he want to learn. So summarize him, and then we want other discussion also, so that everyone will be comfort.
Okay. Well, I'll try and do my best for everybody.
I think he cannot do that personally. He has to do that professionally. From yesterday, the class has started. Everybody has been to on time, and then today someone came. It is the almost 10 p.m. Nepal, 10 p.m. And that guy is coming and say, repeat my questions, repeat my things. Tolerable.
Okay, well,
please, everybody. Mr. Jim.
Yes.
I'm the senior citizen of this class. I told you already. I would like to say all of my brothers, whatever, they are very junior. Don't say like that. Be punctual. Be on time.
Surendra sir, I will be in time from tomorrow, sir.
I'm just trying to help everybody.
Today, let us finish this, sir.
Your name is Prakash Chaudhary, yeah?
Yes.
He was in yesterday.
Surendra Dai. Surendra Dai. पछि कुरा गरौँला यो पहिला क्लासै सकौँ पुरा हामी आफ्नै ग्रुपमा डिस्कस गरौँ किनभने उसलाई पनि अब
ओलीले भने जस्तै नगर न यार
हैन हैन यो एकजनाले गर्दा सबैलाई डिस्टर्ब गर्ने भयो
अहिलेसम्म क्लास सकिसक्यो हैन अहिले यो हामी डिस्कस गर्दा गर्दै अहिलेसम्म क्लास सकिसक्यो हामी डिस्कस गर्दा
कन्फ्युज भयो भनेदेखि कन्भर्सेसन गर्नु ठुलो कुरो हो एकदम गर्नुपर्छ
Are you there, sir?
Jim,
could you do me a favor, please?
Yeah, please go ahead.
Could you explain to the guys that I have finished the subject for today?
Yes, sure, sir. You can leave now, please.
So if those guys don't want to be here, that's fine by me. We've finished for today. I was asked by. Can you just let me speak? I was asked by Prakash because he missed the first part just to go over what I'd done before. So I was doing that as a favour to him. Yeah, so if the other guys don't want to be here, they don't have to be. I have finished the subject for today. If you could pass that on, you could probably explain it better than me.
Yeah.
And I hope everybody knows that. हैन सबजनाले बुझ्यो नि त अब प्रकाश दाइ सायद क्लास गर्नु न अब जसले गरिसकेको छ त्यो छोड्दा भइहाल्यो नि हैन र
म त अलि ढिलो आए मैले रिक्वेस्ट गरेको हो अब
सुन्नु न तपाई अब बस्नु हैन अनि अब यो क्लास पनि भइरहेको छैन डिस्कस मात्रै
तपाईहरु गए हुन्छ नि म एकछिन त हो च्याप्टर 1 मात्रै हो म यो सकाएर अनि त्यसपछि म पनि अफ भइहाल्छु
भन्दाखेरि त्यो त्यसलाई चाहिँ हार्डली वेलकम
अहिलेसम्म सकिसक्यो क्लास
Mr. Campbell.
Yeah.
Are you ready to teach him? We are reaching the room.
Okay.
I couldn't hear that.
Not interested. Leave the group.
Go ahead. Mr. Campbell.
Yes.
You are still teaching him. We don't have problem.
Okay, Jim. Let's finish this. Let's finish this and then
Please,
we can.
excuse me, Jim.
Yeah, okay.
Please, everyone, mute the mic and then tell Jim to continue the class. That is the best idea, I think. We are discussing, and he is also irritating on that.
फोन नम्बर भोलि देऊ अनि म पर्सनली तिमीसँग
Right, what do you guys want me to do?
I want to. Khagendraji,
He
अलि यसो हेड.
He wants to learn on you. That's the problem. We are leaving the room.
Jim, we can start now.
Right, before I go over that material, has anybody got any questions at all on anything that they need to ask me before I do something else? Okay. Yadav, thank you very much indeed for doing that for me.
Welcome, sir.
Thank you. Right, we got to the point where we've got a jet turbine aircraft. We're cooling down the engine bleed air. We're putting that bleed air through an air cycle machine, yeah, where the compressor is running. The compressor is raising the pressure and the temperature of that air. We're putting it through another heat exchanger. It's going into a turbine. The turbine is expanding the air. Hello, she's very pretty.
Who?
Sorry, that's my wife.
Yadav's wife. Very, very nice. Yeah. You're a lucky man, sir. Okay. I notice he's turned his camera off now. Yeah, so we're going to put that through the turbine. The turbine's driving the compressor, and then we're going to take the moisture out and run it up to the distribution side of things. Skip that little lot. The way we're going to control the temperature via the temperature regulator. Temperature regulator is the brains of the outfit, and that is monitoring what's going on, and it's sending out instructions. So the pilot is going to select the temperature he wants. The temperature regulator is going to say, right, he wants, let's say, 20 degrees. And the temperature regulator is going to talk to the mixing valve. It's going to position the mixing valve so we get the right amount of hot air and the right amount of cold air going into the mixing chamber and then going into the cabin. Should that temperature fall, yeah, there's a temperature sensor in the cabin that will say to the regulator, the temperature's falling. The regulator will open the hot air feed from the mixing valve, close off some of the cold air. So now we're getting more hot air into the mixing chamber, less cold air into less hot air into the cold air unit. Yeah, so now the mixing chamber air is going to warm up and the temperature is going to rise. If it goes the other way, if it gets too hot, the mixing valve will work in the opposite manner. It'll close off the hot air. It'll open up the cold air unit for the cold air to go through. The limit sensor and the anticipator sensor are there to stop us getting big blasts of cold or hot air as the temperature changes. It makes sure that there's a nice smooth changeover, a nice smooth change in temperature. Yeah. Other sensors that are dotted in there, within the distribution manifold, we've got a 90-degree switch and a 120-degree switch. 90-degree switch, if the air coming out of the mixing chamber is too hot, once it gets to 90 degrees, the system will trip out. Once it's come down to temperature, the right temperature, we can reset it. As a backup to the 90-degree switch, there's a 120-degree switch. If the temperature carries on rising, gets to 120 degrees, again, the system will trip off. There's sensors in the compressor discharge line. to make sure that the temperature coming out of the compressor isn't excessive. That'll trip the system off if it is. There's a ram air controller, and that sensor is measuring the temperature coming off the compressor, and it's opening and closing that little deflector door to regulate the amount of ram air that we're going to allow to flow over the heat exchangers. Yeah, turbine inlet switch. Yeah, again, we're making sure that there's the correct amount of ram air cooling the air coming off the compressor, so it's not too hot going into the turbine. And we've mentioned the 35-degree switch. What we do is bypass the cold air unit just to make sure that the air going into the water separator is above freezing. Control
okay, Jim.
panel.
This is from where I have continued, so it's okay. Just there is one turbofan valve. You know, in that diagram, there is one turbofan sort of valve.
The turbofan.
Sort of.
Yeah,
valve.
and the turbofan shut-off valve. That's when the aircraft is sitting on the ground. We need ram air across the heat exchangers for them to work. We need to pull air in. If the aircraft's sitting on the ground, there's no forward motion, so we're not getting ram air. So what we do is we take a little tapping from the APU. I've got the turbofan shut valve. We open that valve, and the air coming down hits the turbofan, causes it to spin. As that turbofan spinning, it's pulling air over the heat exchangers. Yeah.
Okay, that's in the case of if the aircraft is on the ground, there is no ram air.
Yes. No ram air.
Yes, Jim. Thank you very. There are compressor discharge overheat sensor and ram air controller sensor. Ram air controller sensor controls the deflector.
Yeah.
And compressor discharge overheat sensor will control what?
That overheat sensor is looking to see what temperature is coming off the compressor. If that temperature is too hot, it will shut the system down. Yeah, the ram air controller sensor, that's looking again to see what temperature is coming out. Yeah, and to make sure that the right amount of ram air is allowed over the heat exchanger. Same with the turbine inlet switch. Yeah, if the air coming off the heat exchanger is too hot, yeah, again that overheat switch will shut the system down for us.
Okay. Okay, Jim.
Really, thank you. Okay.
Yes, Jim. Okay, this is where I have covered this, and thank you very much for repeating me, especially for me. And I apologize if you have any odd feelings regarding this.
I don't have any feelings. No.
Okay.
I'm happy. I'm here to help as best I can.
Thank you, Jim. Thank you so much.
So if everybody's happy, if anybody's got any questions, get them asked. If not, I'll get some questions out to you in the morning. I know it's late there tonight.
Jim,
so
I have very small
same as I did today. I'll get the questions to you in the morning.
Jim.
Yeah.
Do we need to memorize the location of all these sensors?
No.
In exam point of view?
No. You just need to know that they're there.
Okay.
So, we need to know what the anticipator and the limit switch are there for, just to control the rate of change. We need to know that there's a 90-degree overheat switch.
Okay.
Into the cabin, so it's a protection system, isn't it? Yeah. And the other one, the 35-degree switch or the 1.7-degree switch, yeah, we just need to know that that's there to keep the air going into the water separator above freezing.
We need to remember the temperatures. This 120 degree, 90 degree, 1.7 degree, like that?
For those
90,
ones, I would, yes. Yeah.
90 and 120 is important, I think, right, Jim?
Yes, because they are protection. Yeah.
These are the. I think these are the name of the switch, not a degree, right?
No,
Yes,
you need
I
to know
guess
one
so.
operates at 90 and one operates at 120.
Okay.
Yes.
But
Like trip out is on 120 degree.
It'll trip out at 90 degrees and we can reset it. The 120 degree switch is there in case you get a failure in the 90 degree switch. Yeah. So if that 90 degree switch was inoperative for whatever reason, if it had failed and we don't know about it, the 120 degree switch is there as a backup.
So that is for only backup.
Yeah, yeah. So if the 90 degree switch was faulty and it didn't trip the system off when we got to 90 degrees, then the 120 degree switch would pick it up and it would trip the system out at 120. So it's there as a backup for the 90 degree switch.
So if we are asked like what temperature will the air conditioned pack trip out, then it will be 90 degree.
Yeah.
In both case, can we reset it from cockpit? In both case?
Yes. Yes, you can that one.
So what else are important, Mr. Jim? What else are important? Compressor discharge overheat sensor?
In as much as if that operates, it'll trip the system off and you can't reset it. That will shut the system down.
Say again, Jim.
The compressor discharge switch, yeah, if the air's too hot coming off that compressor, if that overheat switch goes, the system will shut down and you can't reset it.
Okay, it's a non-resetable, right?
That compressor one, yeah.
Can be reset in the ground only.
Yeah.
Not in flight.
No.
Okay, then is turbine which drives the compressor?
Yes.
Excuse me, when compressor discharge overheat sensors sense the overheat and the system cut out, the ACM do not function, and when the system revert back, it will start automatically, or it is cut off until the aircraft land or reset it in ground.
Yeah, it's cut off till the aircraft's landed, and you can investigate why.
Okay.
Yeah, with the other two, the cabin switches, you can reset those in flight. Anybody else got anything?
Jim, like in combustion heater, do we have to keep in mind that the cap 747 are these important for this? We have to remember this cap 747 GR11 required.
No, but well, I say no. I don't think so. But you need to know that the heater's got to be maintained every 2 years or 500 hours. Yeah, it's those figures that'll. Anybody else?
No.
In duct construction, what are the important? Expanding
Say again?
couplings. In duct construction, we need to remember expanding couplings, V-band.
No, but that should be second nature to you anyway. The expanded couplings, you got hot air going down a pipe. If you don't give it room to move, it's going to damage it. You know, so it's just there to allow for the expansion and contraction as the thing heats up and cools down.
Jim.
Gas per outlet.
Okay. Go ahead, Harmendra.
Sir, what is gas per outlet?
On there, remember we looked at the little fans. The gaspers are the little overhead louvers. Just give me a second. I'll find it on the
Passenger service unit on the overhead, I think.
Yeah. When I get to it, there you go. The gasper fan is the fan that it's drawing air up to the passenger service unit. Yeah, so that's the gasper fan. The gasper outlets are those little twisty louvers, those things. Those are the gasper outlets.
All right.
And one last question from my side, Jim. What is the difference between the air cycle machine and the vapor cycle machine? What the main difference between them?
Between the air cycle machine and the what?
Vapor cycle machine.
Sorry, I heard. What's the difference between the air cycle machine and the
vapor
cycle machine?
No, I didn't get that. The three-wheel air cycle machine has just got the fan. The common shaft is extended out, and it's got a fan on the end of it that runs in the ram air duct, so it pulls ram air over the heat exchangers.
So you will be giving only the questions like today you gave to Yadav, not the objective one.
Yeah, I'll give the questions to Yadav. I'll do it in the morning, same as I did today, my morning, because I'm going to have a look and see if I can find those levels for you.
Actually, we are looking for some objective type questions. If it is there with the options, then it will better to discuss.
We're not allowed to give those out.
Okay.
We're not allowed to give multiple choice questions at all.
For the practice?
Yeah, we're not allowed to.
Okay.
Yeah, we can't do it at home. We can't do it in Scotland. We can't do it anywhere.
Okay.
Okay, Jim. I think that's it for today.
Okay. Is everybody happy? Anybody else got anything before I go?
Thank you again, Jim, for repeating that chapter 1 especially for me.
Okay, no worries.
And goodbye, and have a great evening there.
Okay, enjoy what you can of your evening, and I will see you tomorrow. Ice protection tomorrow.
Okay, sir.
Okay, Jim.
Okay.
Okay, take care. God bless.